in person here, plus many people online. First, I would like to say big thank you to our partners, companies supporting our event. Without our partners, of course, it is not possible to have such kind of events anywhere. Few words about our schedule. We will start with technical sessions after 15 minutes. From 10:15, we will have short break for lunch, and we will have closing at 5 p.m. And also, we will have very interesting attractions from our partners. We will talk a little bit later about this. So, it is very useful to visit booths of our partners. You can take a look at the booths of MentorMate and some presents from our other partners, and I think you will not regret. Thanks again to our team for the big support for this event. And now I would like to invite here, actually, Christina from MentorMate, because we need to share some information about what they will exactly present here. Just 1 second to reshare my screen. Okay, I think that now it will be better. So, welcome. Okay, let's try to share it also here in this way. So, welcome.
Hello, my name is Christina. I'm Talent Acquisition Manager at MentorMate, and I'm very happy to be here today with you and to be a sponsor of this event. MentorMate is a software development company building specialized solutions for clients from all over the world. I'm not going into more details. We will be here all day at the venue, and you can learn more about us and talk with us in front of the room. More than that, today we have great presents for you. For all of you who are here, can register on our raffle, but also for all of you who are online. And at 5, we will announce the winners of the prizes. Those are the prizes, and we have some more on the stand. So have a great day today.
Thank you very much. And we have another representative of one of our partners. I would like to invite now Ivan Milewski, who will share some things about EPAM. Just 1 second to stop share the screen. So, Ivan, it is your turn.
Thank you. Morning, everyone. My name is Ivan Milewski, and I'm a leading data engineer in EPAM system. So I will say some few words about EPAM, and of course, I try to be short. At the moment, EPAM is a leading platform, engineering service, and also product development company, which is focusing on to deliver some of the best approaches to our clients. Also, we are engineering different solutions with the best approaches, also innovative software, and also with the consulting and some with our different design capabilities that we have at the moment. Also, we are around more than 40,000 people in 35 countries, and we are still growing. So please do not hesitate to check our webpage for our job offers. Thank you.
Thank you. Additionally, you can have here in the venue after 10 a.m. beer, fresh beer from our partners from Amsterdam. So everyone who needs to come here in person will regret. You still have time to come a little bit later because really we will have nice beer and everyone is welcome. Additionally, we will have, of course, different attractions, everything which you can expect for this event. But yes, usually we are starting with announcements about beer. So thanks to Angel for the beer and everything which is actually available here from their side. And I'm not sure if you know a little bit more about this company, you can check. I think that now we will have some short representation from Andrei. Just a second.
Andrei, you're here now, right?
Hi, everyone. I hope you can hear me. I'd love to congratulate everybody on behalf of Anthill. A part of being a sponsor of this wonderful event. I'm also a speaker. And what I want to share is our excitement to support Mikhail Matev and the AI and IoT Bulgaria Summit. Just 1 second, can you hear me?
Yes, I can hear you well.
Okay, I hope you can. So what I wanted to share is that Bulgaria has been a well-known destination for software engineering, for outsourcing services. And what we hope we will become with the help of events like AI and IoT Bulgaria Summit is a destination for true value-added services related to AI. So just a quick note about Anthill. We're a relatively new company on the market. Our main business is creation of product teams. We've been known around as one of the initiator of the ProSieben project, and we're right now present in 3 countries, namely Romania, Ukraine, Bulgaria, and Germany. So we're very much looking forward to continue sustaining the community through events like that, and hopefully that will materialize in use cases that we can share that has been created out of Bulgaria. Thank you.
Philip, we can see you.
Hello, can you hear me?
Yes.
Yeah, there are some issues with the sound. Sorry about that. So, hello everyone, and thank you for being part of this amazing event. The 3 streams, they're amazing, and I see very interesting topics from everyone. And Boshayo, I would like to welcome you to this event. It's very hot outside, so staying at home or going to Sofia Tech Park and listening to some interesting themes is something that you will be happy to today. About Bosch.io, so we are an international company that is part of the big Bosch family, and we are more than 900 experts localized in different locations, and together we create the future of IoT, and we bring the IoT to life. So Bosch is a pretty big company, and together with our colleagues and partners, we bring solutions to life and help people around the globe, making their life easier. And yeah, so happy to hear and to see everyone here, and would like all to have a very nice day, very productive day, and to hear and to learn many new things about AI and IoT. Thank you.
For the whole support. And now, because we are already close to the start,
These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
Start my days, sun rays. I tap the phone, coffee's on. I mow the lawn, and Lucas and Sean. So connected, so effective. I let it drop, clean it up. Heated smart, I do my part. Get in the car. Superstar, they're watching me. IoT, 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 IoT. I check my stock. What a shock. Buy some prawn. My oven's on. Coming home. Future zone. All for me. IoT, 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 IoT. Live like a Bosch, with many connectivity solutions for a smarter future. From Bosch.
Независимо от работата от разстояние, в MentorMate продължихме да бъдем свързани. Работим от офиса, от вкъщи, от всяка точка на света. Това вече е ежедневие. За да отговорим на нуждите на всеки, създадохме 3 модела на работа, от които всеки в компанията може да избира и след края на пандемията. Първия вариант е комбинация от работа от вкъщи и работа в офиса. Комфортът на собствения ви дом ще бъде съчетан с социалните контакти в офиса. Може да предпочетете да работите изцяло от вкъщи, като ще имате опционално място в офиса след предварителна заявка. Искате изцяло гъвкава и дистанционна работа? Може да работите от всяка точка на света, гарантирайки си по-високи доходи. За да осъществим тези модели на работа, ще инвестираме $1 милион в висококачествено техническо оборудване, което да даде възможност на всеки да работи комфортно, независимо къде се намира. Придобивките за хората в компанията също стават гъвкави, като всеки ще може да избира най-удобните за себе си. Като компания, която цени служителите си, даваме възможност сами да избирате. Тези модели на работа важат за всички отворени позиции и не са ограничени за времето в пандемия. Посетете нашата кариерна страница mentormate.com/bg/careers и вижте отворените ни позиции.
Okay. Okay, people, thank you for joining. We are on schedule, and as you know, we're streaming online, so we should be on time with the other people who are streaming as well with us. So we don't have the option to make a delay. I really enjoy being live, and actually, I have lost training speaking in front of people, and it's not that cool speaking at the office with 3 monitors, etc. You're not having real feel and feedback from people. And actually, I expected somewhat 3 to 5 times less people in the room than there now. The topic now is Project Bonsai, something quite new, something which I'm quite enthusiastic, and my team is working, experimenting with it. We're not too much ahead, done something quite big, but let me see whether you'll get enthusiastic after the presentation. So my name is Evelin Andreev. I'm Microsoft Azure MVP, software architect at one Bulgarian company, Interconsult Bulgaria. I'm also a CTO of the Norwegian office. It's called ICB Digital. And let us say that if at some point of time I have spare time, I work as independent expert on some European programs, assessing projects mainly in the areas of artificial intelligence. It seems that there are very few experts in this area, but my primary interests are related to IoT and integration. You know about sponsors, and I'm actually having a couple of hats. One of these hats is I'm helping Mike with the organization, so we really see, understand, and appreciate the support of the sponsors. So this makes the events free, hiring buildings, rooms. When we meet face-to-face, it's coffee, lunch, some small things, but yes, the sponsors make this happen. The agenda about the meeting is autonomous systems with Project Bonsai. You see Project Moab, which is an open source machine teaching hardware kit. It's about balancing a ball, this one. Of course, it's just for experimentation, it's for a walkthrough. But the topics we're going through is autonomous versus automated systems, what's the difference, the history of Project Bonsai, some basic concepts, practical advices, walkthroughs, quick start, and of course, the demo. I will try to leave 15 minutes for the demo, and if there are 15 minutes left and I'm still not at the end of the presentation, I'll just interrupt and go for the demo, because it's worth seeing a couple of things. Okay, autonomous systems, what is this? It is intelligent system, but it is acting in the real world, in highly dynamic environment, physical environment. So Microsoft likes saying that this is getting from bits to atoms, so getting into the real world. The way autonomous system works is by a loop of sense, plan, and act. So sensing is you are having sensors, you are having cameras, and you make a perception, you sense the environment. On the next step, you're trying to interpret this sensor information to act and have some actionable information. But you want to act based on a reward. So there is an AI related to reward. You're getting a reward for your actions afterwards. And at the end, you're acting, aiming to be in proximity to the final objective. Of course, to apply in the real world, one of the most important things is the simulation, which needs to be, we're going to talk about this more on next slides. But the simulation is the thing which is allowing you to touch, to expose the real world to the bits or to the program. You have heard of autonomous cars. I would say that when we get on the next slide, you understand what level 1, 2, 3, 4, 5 means. Now, I believe that we are on level 4. By the way, this is Jaguar I-Pace from the Google project. It was something with W, I don't remember the name. Way motion or something way more like this. The difference with machine teaching and machine learning is that a teacher is telling the machine the fastest way. Probably some of you have at least some tiny little bit of knowledge about what machine learning is. The difference machine learning is different from machine teaching is machine teaching is showing the computer how to achieve the goal fast. Not just here is a bunch of data, just to see what insights you could get out of it. You probably know there is a cool joke about what's the difference between machine learning and AI. It is said that if it is on PowerPoint, then it's AI, and if it's in Python, that most likely it is machine learning. While reading articles, if you have been on some business meetings or etc., you could hear a lot of you could read a lot of articles like what machine learning could do. It usually you do something, you have a black box, you put it there, and whatever you want to do, you just say that machine learning will do it. So this is the way it usually works on PowerPoint. Of course, it's when you get enthusiastic and you want to do it by yourself, you would pretty much realize how limited it is. So autonomous is not automated. What are automated systems doing? Usually automated systems are having a different way of approach. It is like a script, it is like a program which runs, and it cannot do anything which is not in the program. You could do some long-term or short-term objectives like react to wear of equipment, or do some cleaning or diagnostics from time to time, but it could not work in and make not coded decisions. We discussed a little bit the different levels of autonomy. So the first one is human is in complete control. The second one is assistance with subtasks. So basically, let us say that I'm trying to apply autonomous systems at this stage here. You will understand after a while why. And probably let us say that tests will probably have reached that level here. Level 2 is occasional, human specifies intent. Level 3 is limited, human fallback to human. Level 4 is full control, human supervises, and level 5 is human could be completely absent. Autonomous systems are different in what aspect? They should be able to act without human intervention, to sense the environment and fit to dynamic process. Of course, there is disadvantages, drawbacks. First of all, you need consumer acceptance, which means you should have a good explainability why it is making this decision. Is this decision good? Make some analysis and gradually gain some trust. So it's called consumer acceptance. You need to convince the consumer that there is practical use, there is benefit of using that technology. Rather than that, probably if you're developers, I'm not aware of your background, but if you're developers, we like cool technology. But when you step to the business and you want to get some benefit, some use of applying this technology, then things start becoming interesting. So the challenge is not making machine learning or artificial intelligence. You have lots of frameworks out there. The problem is to bring benefit by applying this. This is the greatest challenge. The next thing is, what if the computer breaks? Like you're having a sensor, you depend on a sensor, and once of a sudden this sensor doesn't work. So the technology and the infrastructure is also something important. And the next thing is the security and responsibility. This challenge. If an autonomous car hits a human, or there is a car crash, someone dies, who is responsible for this? So there must be policy and legislation. About the history, Bonsai emerges as a deep reinforcement learning platform which suits these cases like motion control, smart buildings, process control, industrial robotics. As you may assume, I don't know whether you feel this suspense in the air. Microsoft acquired Bonsai some time ago, which means Microsoft didn't create Bonsai, but they somehow found the benefit, they saw the potential in it, and they bought it and obtained this company. You could see the original, probably it's small from the back, but this is the original team from based in Berkeley, California, Bonsai team. This was the original name of the company. They acquired them in June 2018. Microsoft released it in public preview in May 2020, and if you watch some old videos, you could see how things have improved over these years. And now you could freely say, if you go and have a look really, that it is the simplest and richest tool chain for doing autonomous systems, because it is putting abstraction over machine teaching. It allows you to have a generation of models, and it is hosting APIs for the training and for inference, which is the inference is the part where you're using the trained brain or trained machine learning model to do something valuable for you. If we look closely to the project Bonsai itself, it's having a couple of its flow is having a couple of steps. First, it is integrating with the simulator. Then you have the training process, and then you could export the brain, and you could run this brain locally on some edge device, or you could run it in ACI, Azure Container Instance, for example. The cost is completely free in the preview, and we're still in preview, so we could give a try. Speaking of Azure resources which it consumes, it's about container registry, container instance, storage, and monitor. Later you'll see some estimate, but I would say it would cost you about 70-90 euro per month, of course, if you use it full time. What are the components of the Bonsai platform? First, of course, we start with the simulator. Probably, I would say, one of the most, not the hardest to implement things, but the most important things. You need it for a realistic training environment. Of course, the training simulations need to model a real-world process or a real-world machinery. And you need fidelity, which is, imagine the following. If you're simulating a car which is going down the slope, and your simulator is simulating the speed. If the speed which the car achieves after some amount of time is 20 kilometers per hour more than the one in the simulator, or if the one in the simulator is 24 kilometers per hour more than in the real life, then you will have a simulator which is far away from the reality, and you will train absolutely nothing. I mean, it is useless to use it at all. The good thing is that there are multiple supported external softwares for implementing simulators, like AnyLogic, MathWorks with Simulink, VP-Link. I actually have never heard of it, but we'll focus mostly on that part here, mostly because I'm a developer and I have very pale memories on using MATLAB and making models from my master's degree some time ago. So let's say that for developers, we're going to focus on making a simulator with Python by ourselves. The minimum requirements for a simulation is to it needs to have an initial state, which is pretty okay to be a random one. Then it needs to iterate over time, which means not 5 or 10 times. It means millions of times, millions of iteration. And it needs to respond to action. So it's not just simulating, generating some data, but it responds to action like, okay, now you're giving me that data. Now I want to change the temperature. I want to put more of this ingredient in the chemical reaction, or I want to put more force in the engine, something like this. You're sending an action, you're sending a command. However, the requirements for the good simulation are far more different than the minimum requirements. We mentioned about the fidelity, about the difference with 20 kilometers per hour. It could be a difference with 1 kilometer per hour. It is okay, but 20 is too much. The next thing is visualization, so that you could have a good assessment during the training. The next thing is capturing the environment state. Okay, what does it mean? It means if something is happening, you need to be able to capture this with sensors and put it in the model. It's not like something is happening. It is of random nature, or I don't have a good explanation why is it happening. You probably know that let us say in the dark ages, when windows and doors were moving, people are not thinking of airflows; they're thinking of some kind of ghosts at some point of time. So you could assume, okay, if you don't measure the speed of the air going through the window, then it could pretty much say that it is a ghost, but it wouldn't work for the simulation. then you should be able to have discrete actions. Discrete is like increase the temperature with 1 degree, make 1 step forward, increase the speed with 1 kilometer per hour. So this is what it means. And a clear criteria of failure or success, meaning am I close to the point where I want to be, or I completely failed, like I'm trying to balance something, it fell, or I am trying to drive a car and it crashed. So you need to have these criteria. You probably start understanding the complexity of having a phone simulator. The next component is the training engine. The training engine is having these 4 parts: architect, instructor, learner, and predictor. The architect is similar to what a data scientist is doing, evaluating the effectiveness of neural network. It supports 3 types of algorithms, which I just have them written here, but unfortunately I don't have a good understanding of them. It's called distributed deep Q network, proximal policy optimization, and soft actor critic. The only thing I know is the basic way the reinforcement learning algorithms work. But don't worry, this is everything is kept behind the scenes, and there is an abstraction layer which is sitting between these nasty words and you. So don't be afraid. The instructor is about the configuration of the parameters. The learner is doing the training and giving the response back. And in case of inference, when you have a trained brain in your and this brain is you want to use it, then you also use the learner. And the predictor is the HTTP endpoint which you're using when you're hosting in a predictor mode. The next thing is the brain, which you may pretty much understand what is it doing. Of course, it's doing the main work. It is the AI model, which is doing what it is trained for. So it's encapsulating your intent, your understanding of the objectives it wants to learn. It could have multiple versions. It could be exported, as we mentioned earlier. It is a very cool feature that this export is happening very easily. Of course, with Docker is a kind of a standard nowadays. So just go and check the 5 or 10 commands you would most often need to use. But it's exporting it in a Docker container. And this brain is built by the so-called curriculum. And if you change the curriculum, you need to train a new brain. What are the goal objectives? The types of objectives are like avoid a region, avoid a place, try not to be in this place. Reach, which means go to a target as soon as possible. Drive is go to a target and stay near to that target, not just reach this target once. Maximize and minimize are pretty much self-explanatory. So goals are high-level specification of what you want the system to learn. It is an encapsulation of your intentions. Again, one abstraction of what you want to express to the brain. The teaching process is iterative. First, you have training, which is having many episodes, which is having many iterations. Every assessment consists of a series of episodes, and the assessment window is the time or the place where each test episode is receiving a score, and this cumulative score is telling you how close you are to the objective which you want to reach. Let us say that you have thousands of iterations per episode. You could have about a few hundred episodes, and in total, the number of iterations by default they are 50 million. So, how does it look like in the UI of the Bonsai UI? The first thing is this is a so-called concept graph. It's showing the number of simulations. Usually you have number of simulators, sorry. Usually you're having about 10, 20, 30 simulators running in parallel, usually in Azure Container Instance. The total amount of iterations per second varies between 100 and 200-300 iterations per second. It depends on the complexity of your simulation, of course, but I would say for average simulation, you're having a Go chart where you could progress the where you can monitor the progress. You see the simulator, which is used for the training of the concept. Then you are having the simulator state. This is the so-called InkLink, which we are going to talk about later. This means a number starting from -20 to 120. So it is saying interval. This is the output. The simulator state is the output of the simulator. Then there is an implicit conversion to simulator state. So imagine this simulator could have a state, but not everything is visible to the Bonsai brain during the training. So you have an observable state, which is a subset of that one. Then you're having the concept, which is what you want to train the brain for. This is your concept goals, like have some temperature deviation you want to keep to minimum, and to keep a certain cost to minimum. And there is the action. As a result, you have the action, which is saying the simulator sending a command to the simulator, turn the heater on, or turn the air conditioner on, or vice versa. And this is happening in a loop hundreds of thousands of times at least. The InkLink. The name comes from a fictitious Nintendo Splatoon game. I tried to convert a YouTube video here to a GIF so that you could get an impression what are the InkLinks. The InkLinks are some human beings that could transform themselves to squids, and they're painting, and this is the way they fight. By the way, there is going to be a new Splatoon version from Nintendo in 2022. Or at least these are the intentions. And of course, probably you have heard, I don't know, there is the penguins of Madagascar. I'm not sure whether you know the. I'll just switch to Bulgarian in a little bit. Имаше там един екип Северен вятър, не знам дали сещате, и имаше един октопод, който се казваше Дейв. И той имаше едни такива сквидчета, ето бяха, и те говореха някакъв такъв странен език. И горе-долу инклинга говори по същия начин. Нещо. Така, това е истински инклинг. So this is the origin of the inkling language. Of course, it's not like this in here. Now it's proprietary language, which is defining how you want to teach the AI. It is a statically typed language, starts with a version. You could have commands, data types, primitives are number, string. You could have enumerations. The number is specified like 0 to 6. Step 2 means 0, 2, 4, 6. You could have array structures, user-defined types. So it's not that simple language. Constraints, ranged constraints, a lot of. The graph keyword is these are just 4 or 5 keywords which will help you understand the different regions in the InkLink code file. The graph keyword is defining the training graph, of course, and it's having input type and output type, which is the input provided to the AI and the output provided by the AI. I'm not sure how small is it. I should have zoomed it a little bit, but the definition looks like graph input, semicolon input type, output type. The concept keyword is what must be learned or programmed in the brain. There are 3 types of concepts: imported, programmed, and learned. Imported means you have trained it in other platform like ONNX, which stands for Open Neural Network Exchange. If you have worked with custom vision AI, there you can export in ONX format your custom vision model. And TensorFlow, probably most of you know it or have idea about it. Even I think that MLNet is sometimes using pre-trained models which are trained before this with TensorFlow. The programmable concept is you're programming the concept in a function inside the Inkling itself. I wouldn't say that this is of much use because we're not interested in programming it. If we're interested in programming, it's like the automated systems. We are interested in something completely different. So programmed doesn't sound as if it is something to go for. And we're talking about the learned concept, for which you specify a curriculum. The definition of this is okay. The curriculum itself. In the definition, you are having some parameters you could specify, like total iteration limit, which is total iterations for the concept starts from 50 million as a default value. Episode iteration limit is iterations per training episode, which is 1,000 by default. No progress iteration limit is 250,000. It's self-explanatory, so how many iterations you do without some significant improvement. A reward threshold, which is the minimum reward for success. Success threshold is the minimum threshold to complete the training. And assessment window is number of episodes, and when you make an assessment, like you have 30 episodes with, let us say, by default 1,000 of iterations. So let us say that every 30,000 iterations you make an assessment how close you are to the goal. Training stops either manually or when it's no longer improving. So it is, for example, this no progress iteration limit, or some of the limits reached, like training time, for example. The source of this curriculum is our simulator. So it is the data source for teaching our concept. So you see that the simulator is literally everywhere. People, I don't know how many of you are actually tracking the European Championships. Believe it or not, I haven't watched a single minute of these European Championships, so it's a pity. I stopped feeling myself as a real man now. But I don't know, is anything interesting happening? I mean, have I missed something? Yeah. Okay, I'll try to compensate the next couple of days then. Yeah, but more or less I've been sleeping about 5 hours per night the last 1 month. Doing some investigations attempts. Later on you will see a little bit more, but let us say that the templates which you will find online on Bonsai are not working smoothly. I personally reported 4 issues in this. Microsoft were so kind to fix 1 or 2 of them, a couple of some remaining, but this is all taking time. So the goal is the specification of where you want to be when training. Like you say, avoid fall or drive to small angle, and this is having ranges. So if you say that you want to reach the goal, this goal is not like some kind of a specific point in the 3D actually 3D up to 3D dimensional space, and you want to be exactly there. It is some kind of range, because most likely you will never be able to be exactly on that point. So that is why you need these ranges. So you have a range above values greater than or equal than your goal, or range below. Sphere is values within line with a radius r, but it's actually not a sphere. This one is very interesting. This one is a sphere. It's a 3D sphere. This 2D sphere is actually a circle, and this 1D sphere is actually a line. So it's quite a little bit. It took me about 30 seconds to understand it. So these are the objectives we mentioned on the previous screen: avoid, reach, drive, maximize, and minimize. But these objectives are achieved within some confidence level from your, and this is the way it is described in the link. Avoid fall. You're using math function of taking the absolute value of an angle, and this angle needs to be range above max angle. So you should avoid this angle to be more than that angle, because if it is more than 30 degrees, let us say, then the thing which you are trying to balance will fall. So this is the interpretation of that. The simulator keyword, it's probably I don't know which amount of time we are mentioning simulator today. It is our virtual environment to simulate. The Inklink code itself, it is not coding the simulator, so the simulator is coming from the outside, so it is, let's say, importing the simulator. And the simulator statement itself is having the action type, config type, and state type. If you remember when we went through the loop and the diagram, the most important thing is to react on action. This is to react on command. So if the simulator is giving an output, tell him, okay, now I need to correct something. The configuration is the input, and the state is the state of the simulation itself. So we're going through this probably for the third time on this presentation, but it's a good for the general understanding, I believe. Okay, the simulators, you have two options for the simulators. The first one is using a thing like AnyLogic and MATLAB. By the way, it is good that you're having free trials of this. If you're going for a paid personal version, it is going to cost you about 2,000 euro. But if you want to experiment at work with your projects and do something commercial, then you have to pay another type of license, and even the price is not always available. You know that scenario. Okay, we want to talk to you to understand what you're trying to do, to tell you what the price would be. So the process that you're having really thousands of ready codes and samples, and let us say that some of them are going to be reusable to a certain extent. It's highly graphical, but the cons are that it's extremely steep learning curve. It's very difficult to understand. Usually people from the academia are using such tools. So I wouldn't say it's, if you're not doing it for living, most likely you're not going to in this direction, or if you're not having a certain background from the university with it. And I was having a semester with MATLAB, and it was still difficult for me. And these are taking also resources. You also need to code here and there. It is like coding in Jupyter notebooks if you have done it for some machine learning tasks. The custom simulators are more interesting for people like us. You're implementing them in Python. You build then a Docker image. You push to Azure Container Registry, a place to store your image. You could consume from Bonsai portal when you go to, say, an add simulator, or you could automatically register it from the Python console. The process that you're in complete control, no upfront costs, but it is a kind of a developer approach. You are doing everything by yourself. We're having a simulator which is in C# code, which we are now converting to the Python. And let us say that the estimate is 4 or 5 days for writing some good simulator with real use. Again, a reminder of the way it works. The AI agent is sending an action, the simulator is reporting its state, and there is a reward which is about the tuning of the parameters of what we're learning. Going a step closer to a demo, let me see how we're with the time. Okay, fine so far. There are things called accelerators. The accelerators, there are three accelerators which are available online. The two of them are using Simulink. As I mentioned, you could enroll for free trial for both Simulink and AnyLogic. The chemical reactor optimization, you could see, I don't know whether you could see it or it's too small. The chemical reactor optimization, the chemical reactor is quite a complex process, although it appears that it is something, you just put one ingredient, one reactant, then you put a second one, then some reaction is happening, and then you have something third outside of it. So it is not that simple, because the process of reaction is quite dynamic. It is emitting heat, it is emitting other gases, it could be even fire, it needs to be cooled down, and all these relations are non-linear. The next thing is the factory logistics. It is about resource allocation in a factory while trying to optimize the operational costs of the manufacturing. And which is the building energy management. The example which I tried was the building energy management, which is you're having a central heating and cooling systems. In this is actually the model which is in MathWorks. I just took a screenshot of it, and actually this is only a part of the model. And there. What is happening with this one is you're turning on the cooling system, the heating system, trying to balance with the cost of power and energy to keep reasonable limits of the temperature for living creatures inside, like human and keep certain comfort level. With accelerators, when you let us say install them or provision them. You start there from GitHub. The project Bonsai, it's free for now. We talked about this. The simulator software, AnyLogic or MATLAB, it's having a free trial for 1 month. The Azure service, they say that they're using D2V4 virtual machine, but they do not, because the template which was using this didn't work. So this was one of the things which we reported. The error was very easy to fix. It was trying to use from Azure Container Registry an image of virtual machine with operating system, which wasn't maintained anymore. This VM D2V4 is the hardware, so these are two different things. When you're provisioning a virtual machine, you're having an image of the software itself, which is a certain OS version, and the hardware, which is what you are paying for in Azure. Public IP, Azure Container Registry, hard disk, so it's going to, experimenting with the accelerators is going to cost you about €90 per month. And as mentioned, the templates didn't work from the very beginning. So if you go to Bonsai Solutions Accelerator, the guys at the time when I checked, they wrote me an email. They fixed, what did I actually write here? Updating Windows 10 SQ. So SQ stands for Stock Keeping Unit. Like if you're having an online shop, everything which you're having in your shop is called Stock Keeping Unit. So this is the way they also label some of the services they have. This is a screenshot from the Bonsai UI, and this is trying to balance the so-called cart pole sample. You could find it on GitHub. There is a reference from the Microsoft documentation to it as well. For now, it is for you. It is good to know there is a custom simulator. There is an example. So I'm far away from thinking that you will be able to remember everything. But as far as you know, some certain things that that they exist, they are there. And if you have interest, you could go and check. I'm perfectly fine and happy with it. I mentioned earlier that it is good to have a visualization so that during training you could have a real-time assessment. But for now, it is not supported, meaning only for the sample MOAP project and the cart poll, only they are having such visualization. And of course, there is a visualization for those that are using AnyLogic and MathWorks. So in the cart poll inklink file, you will find something like const simulator visualizer / cart poll with /. And yeah, whatever you do here would not work. And the guys from Microsoft, someone there is a tech community forum. A guy asked about it, and they responded to him. We don't yet provide support for custom simulator visualizers in the web interface. The mechanism we have in place for the CardPole and MOAB sample project is provisional, and the interface is likely to change if and when we introduce a way to extend the platform in this manner. So yeah, it's a nice feature. We would love to have it, but no, you could not have it soon. Sounds like that. The takeaways, what you are, you are just about to have exactly 15 minutes for them. It's good time. The takeaways, first, you could understand more for autonomous systems in Microsoft Innovation Tech Hub, like news, concepts, recent developments. I would say it's giving a presentation. It's elaborating on some general terms, concepts, and marketing stuff. The next thing is the Bonsai portal, the so-called Bonsai UI, which is in previewbons.ai. This is the thing which I'm going to show you after a while. It seems I opened this quite recently, that one. This is the community forum where you could ask questions. You mean there is difference. Asking questions is one thing, and getting answers to your questions is another thing. So I would say that the chance of getting your questions responded is 30%, I would say, from what I have seen. But at least it is better than Bulgaria. When you asking questions in the forum in Bulgaria, you usually get an answer like, I don't understand why you want to do this. Okay, I want to do this. I know why I want to do this. Why are we disputing this topic? If you have any valuable thing to say, please say. If you do not, so if you get an answer, it would be most likely a good answer and response. The next thing is the accelerators. This is, let us say, the starting link. What are the Bonsai accelerators? And you already know that there are 3 of them. I'll show you after a while how to provision one. No, I will not provision itself, but because it's going to take, for example, 40 minutes only for that part, and we don't have that amount of time. And we need to do some fixes by ourselves because it wouldn't work. I have a fixed accelerator sample, and I raised the topic in the community. I didn't get a response. Then I fixed it by myself. I reported back again what I did. I wrote to the product group. Then in the product group, 2-3 days later, someone replied me that thank you, we made a fix, etc. Do you have anything else? I reported 3 more things. They said, do you have would you mind writing them as issues? I also reported them as issues, and yeah, we're waiting for them to make a fix. They're end-to-end walkthroughs on Project Bonsai and AnyLogic. This is the first one, and the second one is a walkthrough how to make more complicated, advanced improvement of the project MOAB. I was trying to obtain Project MOAB hardware, but I didn't manage to, which is a pity. But as soon as they respond to me on the reported issues, I'm going to ask about that one again. And the custom simulator sample, which is the CardPole Pi, we mentioned a couple of slides. So we're switching to the demo. These are our next events, which is the Data Saturday Plovdiv. I usually do not travel to Data Saturday, but you probably know that this is the new name of SQL Saturday because PAS, who are organizing SQL Saturday's event, they, I would say, bankrupted. And Data Saturday, the new name of SQL Saturday, is 9th of October, and our largest conference is JS Talks in November. I'm pretty sure that it's going to be a live event. So, changing the way I'm presenting now, and we're having almost 15 minutes for the rest, which should be to some extent good, I would say. Well, okay. First of all, let me just show you how the accelerators look like. So there is a help for the Bonsai Bonsai project. Here is what are the Bonsai accelerators, the 3 different accelerators. So if you go to the chemical, smart energy management. You have a very limited amount of information here. And then you go to another documentation. And when you go to the deploy, a certain amount of things start happening. I'm not. My previous presentation for Azure was for delegated resource management, but the basic concept is, if you don't know what is delegated resource management, you're having for example, you're the customer, I'm the provider, and I'm publishing. Okay, I'll make an example for you about this. This is not time of advertisement, but this is the platform which our company is working. There is a free trial button. And when we go here, we could say delegate subscription access. What is happening now is that I'm starting to install a template provided by the provider. And it is filling for me custom deployment. Here is information which is the subscription, and I'm giving access of the some resources from the other subscription of the provider to my subscription. So what is happening is they will be able from the outside to install resources in my subscription. So we're also doing it. This is a very cool feature. Go and check for Azure Lighthouse before it appears. I mean, it took me really a lot wondering how to do a thing like this. So with the same thing is used here as well. So with the deploy build energy management solution accelerator, you do almost the same thing. This is the quick start. Provision with Bastion, or I don't know whether you know what Azure Bastion is. It is a service in Azure which is allowing you to reach your remote desktop virtual machine, but not using RDP. You're only using the Azure portal itself to establish a secure connection to it. So it is doing the same thing. You just click and it starts installing resources in the same way we discussed some time ago. So you could inspect the Azure deployment template from here to see what they are trying to do. It's really a thing to go for if you haven't done it, and if you're interested in Azure, go and have a check. So after this deployment finishes, and as I mentioned, they fixed it because it didn't work, you would receive a virtual machine. Okay, did I open it? Yeah, I opened it. This is the virtual machine which is created with some things on the desktop. As soon as you log into it, it is installing a script which is installing Edge 11 latest version. Of course, it's Microsoft. It has to install Edge, not Chrome. It's installing Edge 11, pip package manager, Bonsai CLI, Docker instance, creates a container image, then adds the package to Bonsai workspace. Then creates a new brain and opens the MathWorks Bonsai UI solution docs. Everything that is happening during this deployment of the accelerator. With the MATLAB Online, I told you that there is a learning curve. You need to make a self-registration for a free trial. As soon as какво казваш?
Защото в друга машина. Ти си шерваш другия десктоп, ти си шерваш виртуалната.
А това вижда ли се сега?
Аз съм виждам, а другото не. Ти трябва да кажеш на другия десктоп да се шерва, но това не знам дали е възможно.
Добре. А това вижда ли се? Да. Добре. Деца вика, нямаше така да го знаем. Да. Така, okay, so after setting up just a couple of seconds, Steph, according to my estimate, I should have about 10 minutes, roughly. I should have roughly 10 minutes, I think.
Yes.
Okay. After you make your self-registration to MathWorks, there is a file here you need to upload. This is the run setup MATLAB, that one, and it does the job. It takes 20 more minutes to for this to happen, and you receive this file, which looks pretty much like Jupyter Notebook file. I think that the simulator could be. No, wait a second. This is the Bonsai Train M. Wait. Come on. Okay, I'm not sure why. Okay, I was trying to show you how the simulator looks like in MATLAB, but it seems that, okay, I should have waited a little bit. So this is how the Simulink simulator looks like. And as I told you, there is a pretty steep learning curve, and I just tried to edit it a couple of places and I broke it. So yeah, there is a challenge there. What is how are things with the Cartpool Pi? The Cartpool Pi itself, yeah, wait a second. Am I having it open anywhere? Here it is. The Cartpool Pi is a Python simulator which you could use. Setting it up is having some challenges as well. They're saying in the very beginning that you need to first register a few environment variables. They're not saying whether these should be global variables or for the user only. Then they say that a very important thing here is to use the sim workspace to create it as environment variable and access key. How are these obtained? When you go to the, okay, I'm closing here the MATLAB, going into the UI of Project Bonsai. When you go to that one, that URL here, this is the Bonsai workspace, some general information which you have. So we go to get started. And in the workspace info, this is a very long line, but I guess that this is the workspace ID. This is what you need to configure. Then it appears that there is a bug and it doesn't use the workspace. It is not taking the workspace ID from the environment variables. So you need to pass the workspace ID to the either to the Python or to the Docker container. It has two deployment options from the command line. So this is another thing which they shall fix for now. So the important thing is use the workspace ID, but send it as an argument. And there is an example here in GitHub where while they're saying Docker running the container, they're passing the sim access, sim API host, sim workspace. Here you shall put the workspace ID. So this is the way it works. Without sending this, it wouldn't work. So this is the strange thing you need to know. So this is zooming a little bit. So this is the Cartpool Pi. I cloned the repo locally. I have it, and I'm about to run that one. Yeah, someone may go and steal my workspace ID and my access key. I'll soon invalidate it, so it wouldn't be that kind of a problem. But now I'm going to start the simulator. So it said registering the sim. So the simulator was now registered in Bonsai here. Here it is. I'll stop it. Okay. I pressed Control, attempting to unregister the simulator, so it unregistered it. So with this Python command, you're registering or unregistering the simulator. So it disappears from here. So I'm going to start it once again. So this one is registered. It will soon appear here. I hope so. And we will go for a debug. Okay. So I'm picking my simulator, going for the debugger, and I could introduce steps. With this plus sign, I'm putting steps of different type. So this is step, start, finish, or unregister. And the last one would be finish. Then I'm going here, starting a simulator session. And now I'll say run to selection. Oops, sorry. Run to selection means I need to go to the last one. And so this is what is happening. It is sending, this is the state of the simulator. Let us go and see what is happening here. It is communicating with my Python simulator locally, setting episode step. It's setting reporting what type of event was received. Okay, part of it. So this is the interaction of the simulator. After you train a brain, these are my trained brains. I have one for card poll, for example. This is the Inkling file. Oops, sorry. Unfortunately, I cannot zoom it a lot, but it is having we discussed about some of the goals, avoid the concept, the curriculum, training. The command it receives is a command with between -1 to 1, -1, 0, or 1. It is the direction to apply the force to. You click train in the training process start, then there is a visualization which you could see under. I'll spend you 2 more minutes on this stuff. So on the training, you see a graph of how the training process went itself. There is the assessment, which we discussed what the assessment is, evaluating how close you are to the objective. And there is export brain. When you click on export brain, you decide what is the architecture to which you want to export. Because I'm going to run it locally on a Docker, I need it to be Linux x64, but there is also ARM architecture which is supported. After you export, it appears in Azure Container Registry, and here it appears here under exported brains. And here you say view deployment instructions, and with these deployment instructions, you log into Azure Container Registry, you pull the image, and then you can run it locally. About 1 more minute. Wait a second, minimizing that one. So this one is Docker run. I can in the same way I ran the Python script. I can have a Docker image with that Python script. So I was having that in that window. And the other thing is running the Docker container with a trained brain. So I have it running. And we can see it even in the container list. In the container list, there is this is Docker desktop. You have a thing called open in browser, but it's not opening a very nice URL. Actually, there is a Swagger. So you add this v1 doc index HTML, and there is a Swagger, which is we're documenting our APIs also with Swagger. It's very cool, but it's interactive and allows you to I will refresh that page so that you see how it looks. I want to try it out. It generates for me a request body. I'm going to change it to -10 for angular velocity, saying execute, and I receive a response which is saying a command -1, which is the force I apply. This is the command. If you remember the Inkling file, this is from the curriculum, and the commands. This is the sim action. This is what is the output. Or if I change it to something else like, I guess it's going to be 0 afterwards. That's command 1 or so. So basically what I showed you is in the demo very briefly is if you're interested how to install the accelerators, the simulator, which is the Cartpole Pi, the installing the accelerators are helping you by setting this virtual machine from which you could experiment. But you see I was switching, so because I'm having Docker desktop on my computer and Anaconda as a Python distribution as well. You could create your own simulator with Python, the so-called Cartpole Pi. You saw the way it is registered, the way you could debug the assessment window. We didn't get into many details about the Inkling code itself, but we went through the main keywords in the presentation. And after you're ready, because of course you want to have a value, you want to use it, this brain could be exported. You could get it locally in a Docker container, run and use it as a service. So basically, this is a recap of the demo. Thank you for your time. We are 3 minutes after, but we'll stop the stream, and you have any questions afterwards. Most likely, I don't know. Maybe I'm not able to answer to everything, but at least I will try. Thank you for your attention. Ако имате нещо да питате.
Тоест, правиш един, казваш от какво имаш нужда, това нещо ти го симулира, научава се, прави един тъпен модел.
Не. Симулатора си го пишеш ти. Например, ние имаме едни бойлери за едни норвежци, които се опитаме да симулираме, и там идеята ни е, това, което се опитаме да научим е цената на електроенергията варира в различните часови диапазони. Демек от рода на сутринта, която е, представи си сутринта между 8 и 10 и вечерта от 7 до 9 е най-скъпа електроенергията, примерно. Кога да нагряваме, така че да имаме винаги топла вода, и използваме на базата на Time Series Forecasting, гледаме колко е използвал човек, гледаме какви очаквания имаме, на базата на текущата налична енергия и това, което очакваме за разход, опитваме да видим каква ще е консумацията и как да отместим тази консумация във времето. Тъй като да кажем, че ако нагрява един бойлер примерно за 4 часа, изтиването му е за 2 дена, нали? Смисъл, можем да си позволим да го отместваме. Така, на това сме си направили симулатор, който го написаме първо на C#, да видим дали така, защото да не се фърляме първо на дълбокото. И сега се опитаме да го напишем на змийски. Тук симулатора е извън Python, извън Bonsai UI. Нямаш възможност да си опишеш симулацията в Bonsai UI. Така че той е настрани. Него можеш или да го направиш с AnyLogic или MATLAB, а на мен там е много тегаво. Тоест, оттам takeaway за мен е, пичове, много ще й помогне да си стъпнете средата, ако ползвате акселератора, нали? Но аз там не се бутам, защото трудно ми. Не можа да се оправя. Може би, не съм се отрепал от учене, ама някакси безполезни знания ми бяха за мен. Не идвам оттам, не си скарам с това хляба, не мога да го приложа, така че гледа да не тръгвам в тази посока. Така че симулатора си го пишеш на Python и той ти идва отвънка. След като той ти идва отвънка, в Inkling файла, който е в самия Bonsai, той ти дава възможност да кажеш какво искаш да научиш, каква е концепцията, която искаш да научиш, и имаш основните неща, на които казваш му, искам да авойднеш, искам да се приближиш, това казваш му обективите. Това се опитваш да научиш. Имаш от симулатора текущо състояние, трябва да реагира на действие, на брейна трябва да получи информация за състоянието. Заедно с този Cartpole Pi, като си го инсталираш, в инструкциите пише едно друго репо Microsoft да се добави към и по пъти инсталирано друго репо. Там има, реално той е рапър на API-то на Microsoft и там има бъгове. Въпросния Inkling, той ти дава тази абстракция да кажеш какво искаш да постигнеш и всичко отзад седи, ама какъв reinforcement learning алгоритъм ще присъства, и въобще никой от вас не се изисква да навлизате в тази дълбочина въобще.
Само обясняваш докъде да стигне и от какво се пази.
Да, обясняваш какво искаш да постигнеш. Имаш симулатор, който трябва да моделира това, което се случва в реалността. Той седи отделно извън платформата, има интерфейс към него.
Беше направен слайд, в който мозъка беше свързан с симулатор и симулатора връща към мозъка.
И да, брейна, това, което виждаш там брейна Bonsai UI, примерно. А симулатора е нещо отделно. И примерно имаш интерфейс за него, т.е. някакъв плагин такъв външен. Обучаваш го вътре, какво прави, струва, така нататък. И можеш това, което си получил, да го експортнеш в Docker контейнер и да си го ползваш. Или ако искаш като сервис, или може да го хостнеш в Azure Container Instance, който аз тази услуга не мога да я понасям, поради простата причина, че един месец харчих над 1000.
Do you know how to become a technical lead? Well, we have the answer for you. It's MentorMate Technical Lead Accelerator. It's a one-month training program for senior developers of any technology, which will help you build your leadership skills, give you access to a variety of trainings,
as well as a personal budget of 1,024 BGN,
and a personal mentor that will help you along the way. Sounds intriguing? Then apply from the link below.
Start my days, sun rays, I tap the phone, coffee's on, I mow the lawn, impressing Sean, so connected, so effective, I let it drop, clean it up, heat and smart, I do my part, get in the car, superstar, they're watching me, IoT, IoT, IoT. IoT, IoT, I check my stock, what a shock, buy some prawn, my oven's on, coming home, future zone, all for me, IoT, 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 IoT. Live like a Bosch, with many connectivity solutions for a smarter future. From Bosch.
These days, if you don't have an app, you're falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one. These days, if you don't have an app, you're falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
I start my days, sun rays. I tap the phone, coffee's on. I mow the lawn, impressing Sean. So connected, so effective. I let it drop, clean it up. Heated smart, I do my part. Get in the car. Superstar, they're watching me. IoT, 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 IoT. I check my stock. What a shock. Buy some prawn. My oven's on. Coming home. Future zone. All for me. IoT, 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 IoT. Live like a Bosch, with many connectivity solutions for a smarter future. From Bosch.
Независимо от работата от разстояние, в MentorMate продължихме да бъдем свързани. Работим от офиса, от вкъщи, от всяка точка на света. Това вече е ежедневие. За да отговорим на нуждите на всеки, създадохме 3 модела на работа, от които всеки в компанията може да избира и след края на пандемията. Първия вариант е комбинация от работа от вкъщи и работа в офиса. Комфортът на собствения ви дом ще бъде съчетан с социалните контакти в офиса. Може да предпочетете да работите изцяло от вкъщи, като ще имате опционално място в офиса след предварителна заявка. Искате изцяло гъвкава и дистанционна работа? Може да работите от всяка точка на света, гарантирайки си по-високи доходи. За да осъществим тези модели на работа, ще инвестираме $1 милион в висококачествено техническо оборудване, което да даде възможност на всеки да работи комфортно, независимо къде се намира. Придобивките за хората в компанията също стават гъвкави, като всеки ще може да избира най-удобните за себе си. Като компания, която цени служителите си, даваме възможност сами да избирате. Тези модели на работа важат за всички отворени позиции и не са ограничени за времето в пандемия. Посетете нашата кариерна страница mentormate.com/bg/careers и вижте отворените ни позиции.
Enable you to have a break. Yes, you get something to eat. Okay, I need to move on this part because, okay, this is also a canned presentation. So let's start with the start. It's my great honor to be yet to another edition of IoT Summit. I believe I've been from the
very first one. I really love to speak in Bulgaria, and I know that you are interested in the subject, and I've seen how the stuff was growing here. But okay, all right. Who am I? I'm coming from Romania, which is very far away. Yes. We share borders, and let's say we change borders, but we are not having any big difficulties with that. I'm a solution architect for a company called IoT Solutions. And we do IoT even before IoT had the name. What other credentials I have to, I hope that if I'm doing this, nobody's hearing over the live stream, my rating. So, from the year 2011, each year Microsoft awarded me the title of Most Valuable Professional. And let's start, because I really love that we get back to live presentation. Any of you have been to my presentation before? Yeah, Orly. You know what's here? The hardware, of course. Yeah, you'll have a hardware like mine. So, because you know, Romanians are. This I have a problem with the fellow Romanian speakers because they say I'm saying bad things about Romanians. If I ask him about, if you are thinking about Romanians, what they say? They are wonderful. They are slim. No, they are lazy. I got this answer here, and because I'm lazy, you're going to do the presentation. I'm going to give you chocolates. Okay, moving forward. Also, I'm for a couple of years I got the title of Intel Solution Software Innovator, and also I'm an active Microsoft certified trainer. Okay, today we're going to talk about OpenWine. Has nothing to do, unfortunately, with wine. Yeah, but and also, please, I'll give you chocolate. Do not ask me from what is the shortening of OpenWine. Open, I know. Why not? It's something like inference, neural, whatever. But I'm going to give you the, let's say, the overview. How to start, why to start, and okay. We are. I'll show it with some different hardware. Okay, I can ask you if you know what's this.
Hey, this is Intel device.
Yeah.
Yeah, I prefer the Intel device.
Yeah, and you can pass it around or read it. Look
yeah.
at it. Okay, for another. In which town? Let's put this Africa in Timișoara, in Romania. In which town was this device developed? I can tell you which town I'm from. Yeah, Timișoara, of course. You know, this is a very strange and interesting success story. It was, getting back here to the mics, it was a guy that started this a long time ago. And Intel at the end bought the product. The guy this year retired and got the first wafer of the processor. Why it's strange? Because in his interviews, again, this is a bit of banter to get, let the people get in. It has a very strange story, like coming back from work in the West. Somebody drove him and stole all his money, which he got back from working in the West. And yeah, I hear this story privately, but I didn't not ever believe, like general manager of Intel Romania will say this in interviews, because it's pretty strange and far-fetched story. Okay, I'm drunk in a train and somebody robs me. Whatever, but the stuff works and we'll see it at work. Okay, send to the sponsors. And I believe that, okay, Orlin has an advantage. You can guess how much more slides I have. Again, 1, 2, 3.
Four.
Let's see. Something like this. This I will show later when we talk, but let's say, I hear in the back, who was expecting a bigger number? Okay, I'll give to them, let listen to. Even though my wife is here, so, okay. Until I give chocolates. How familiar are you with computer vision? What are the tasks that we need to do in computer vision? For example, you know what segmentations, what is classification, what is, or we need to, let's do it. Okay, I'll show you some pictures. It's not, I'm not endorsing the product, I just find a very nice website which explains you all this. Let's go to the, I should have a browser. Yes, I still have a browser. So, I need to say more, or let's say more. Oh, thank you. Use it later. So, these are the terms of computer vision. In short, it's not. I'll get back to it. It's not atomic science. It's something that we can use tomorrow in the projects. But okay, classification. It means in a picture, I'm looking for only one thing, and I want to see if I have an element here. And I found it. This is called classification. If I know where I have the element, it's localization. When we have multiple objects, I want to see what objects I have in my pictures. This is detection. And where they are, this is segmentation. Okay, I'm talking, this is not the Buck Rogers technology. This is something that you can use tomorrow. How do we get, how I started getting into this? I'm talking from real experience. We had a very smart project because we already decided the Romanians are very hardworking. And so the project was in this manner. They had to put 6 screws of the right kind. And we discovered some people who don't know how to count, and some people are far more powerful than smart. So the solution, the first solution, they come to us, say, we are working with us, let's try to do something to ensure that they will put 6 screws, and they try to put it the right kind. The normal 1980 approach or 1990 would be to put the weight counter. You have a weight counter, and you have an analog digital converter, and you get the right weight, and you add the XZ decimal, and each iteration will get you a better precision. This means that you're going to spend time. You will compare weights, and that will work. But I'll say, I'm Romanian. I know that we can. So if they can do something to have the same weight. So because
here's the same.
No, we are professionals. This is
sorry.
This is the same discussion I have with my wife. They said that in the Serbian state it's stealing. Sorry, we are professionals. So what was the idea? Well, was to put a camera and take the picture and do, I believe that this, and okay, let's go a bit more. Not this, this. This is something to count objects. We did not have the budget. We got the budget for a weight counter to do some hardware and a bit of software. So still using AI, we train the images, but we're very lazy in doing it. We're able to do this project in the same money, and we get a far better customer experience. And we started from really practical zero. And imagine that you can apply the same skills going from zero practical to doing something for you, for your company, for something. And the results are quite different. Now we increase the, let's say the Romanians have less chances. We're getting to 99 error-free time. We had a problem with the training, but we'll get back to that. And also I will show you some way of mitigating it. But let's now go for what's the stuff with OpenWino. OpenWino, we'll get back to it. And also for some chocolates. We'll get to the, you can be lazy. But because we move a bit, let's see a bit about this. What's that? Any ideas? For a chocolate?
Flow. A flow.
Okay, a flow. That was a, yes, it's a flow how to do a computer vision solution. So what's the story with it? We take a bunch of images. Okay, you need to annotate. This is, I will tell you a bit later. You need to do some pre-processing and model training. So this means that after you do the annotation, and I'll get back, or maybe you can tell us what's an annotation.
Labeling.
Who was with labeling? Sorry, without my glasses, I'm working on
putting labels on the images.
Yes, you really earn your labeling. Labeling will get the tool. But we can get a bit back to it. And here we have a model. And afterwards, we do the inference. So we get to, we throw new images at these models, and we get the results. Again, for the newbies in the computer vision, in artificial intelligence, how is this the results? It's a yes, it's a percent, what it is, or it's a name. Or the pictures of Catalin. I say it's Catalin. What it is? Percentage. Oh, take a big one. A percentage. Always in artificial intelligence, you get percentage. It's something like 90% that I'm Catalin, or it's 90% that are the right schools. And like this, we are talking about percentage. It's not certainties. That should not be a shock to you. Use it. Also, it's your job here to establish the baseline. Okay, about being the magician. Here I have first the timesheet for this. And here I will read a bit from this because there are some terms that I don't understand when talking about OpenWino. No, I understand the terms, but it's something like I always forget. It's bechamalization. So, okay, that was the magician part. I explain you what would be later. We talked about labeling. Okay, let's first establish what we're going to put the OpenWino. OpenWino, it's here someplace. But in this part, we'll get back. I'm just building excitement. And anyhow, I want to look smart. So I need to confuse you first. So then I can give you the stuff. So this is the boring way of doing labeling. Anyhow, it's not, you should understand that artificial intelligence needs to have, let not be in the cancel culture, you need to have black people working. So somebody needs to do this. This is the tool that we hate. There is another option which is, let's say, a bit better, but still you need to do it by hand. So essentially you need to draw boxes and say that the cat is cat. Even though I have a cat from Bulgaria, which is more like a rat, mean rat. Yeah, but still, it's under a cat. There is Azure Cognitive Services, and you have a better tool. Or Amazon has a service. and which they literally pay Indians to do a job for you. So that's that. Bear in mind that this is absolutely like in programming, garbage in, garbage out. If you are lazy, like Romanians, and you are working with Romanians, you have unexpected results. For example, we had a problem, and we'll get back to it when we show the open line. We had a problem with bluing. Sometimes if the Romanians, when they are doing the screws, are doing them too fast, the screws tend to be blue.
Yeah.
Yes.
Spiral.
Yeah, because of the
force.
Yeah, it's faster, it's higher temperature. And we trained the module with German screws. And of course, okay, the rule of the thumb on this would be that it helps to do image processing before, usually getting to black and white or to another spectrum, to draw out this variation. Okay, because you are Romanian, we are lazy, we just do more pictures and retrain the model. So yeah, you have also this option. And also here before, let me tell you something. Usually the training of the model, you're trying to do it on real hardware. Because here you're taking a lot of stuff, you're doing number crunching, they will get their ideas on what's that. And again, I'm still checking if we are on time. We're getting a lot of images, and you need to get what's inside. You put a stupid to get a common point. And sometimes the new images can get back to retrain the model. I'll say OpenVino, it's not to that level, but there are cloud offering around it. So let's get rid of chocolates, because it's not good to be on my, from obvious reasons. It's not good to be in my bag. So what's that? Or the one before? Why is this cafe? Because it should be this. Still not this. I have this.
What is TensorFlow is the question.
Yeah, what's TensorFlow? What's cafe? What's a fish? MXR.
Yes, okay.
Yeah, so. Yeah, it's a framework. Okay, what's the story of all this? If we get some, let's get back to, I believe that this one is. The models could be in different formats. And these formats grow like, we have like champignons after rain. You have an inflation of models. You have TensorFlow from Google, you have Cafe, you have a lot of models. So you have a lot of job. Okay, if you are taking a model from the internet, pre-trained, and it's not in the format you expect, you need to change all the software around. Again, stuff that I did not mention at the start. This is a presentation more for developers than architects. So they show you where to go. Okay, this is part of the problem. We have a lot of models, a lot of way in which some artificial intelligence has trained the stuff. We have different formats, so we need to change the code. Okay, going back to Intel. Intel is doing a lot of hardware. Yes, a lot of hardware. So the problem is it's in this manner. They have a different kind of processor, i3, i5, i7. Wonderful. They have GPUs board, several. They have new. Yes. And what will be the message from Intel? You know, if you have a model, now you have decided on which model. You should create a code from for CPU, create a code from the neural stick, and all day long spend doing this. It will be a successful message. I believe not, my opinion. So the idea was, what if we do something in which you can draw any model and you can run it on any hardware? You do not need to change the code. And that's OpenWINO. Okay, how the stuff is working? Let's see if the slide is at order. I think it's better to show the slide. Yeah, it's better. Up there, it's how it happened usually. You have a model and you need to change the framework by yourself. So you have a lot of work. Also, changing the model, it's not trivial. If you're going from TensorFlow to Caffe, you need to change everything and anything. Here, with OpenWINO, you are getting any model. You're running through the model optimizer, and you're running on the inference engine, which is the same for all OpenWINO. Inference engine, you can call it from C++ and Python. Okay, C++ is a bit old, but Python, everybody who is a lot younger than me, which is a big part of the population, will use. Also, I see here something. Model optimizer. What's here?
Infrared.
Yeah, that was the.
I'm not so young.
Yeah, but this is intermediate representation. What they are taking? They are taking all the model. They are doing some optimization. And afterwards, they are representing it at an intermediate representation. Now look at it at the paper. Okay. First, the optimization it's working has two steps which work. First step work in three parts. Three parts it's hardware agnostic. First part is doing bechamalization, layer optimization, all the stupid stuff which is not dependent on the hardware. The second step is looking at kernel optimizations. Usually, all the models are represented in 32 floating points, 32-bit floating points. But some of the processors are suboptimal on this. And they know which processor you target. You tell them when you want to do it. And they change it to the correct one. Also, the third step, they are doing memory optimizations. To rearrange the data in the memory to have a, let's say, a simple model to do it, to start with it. And in the second step, they are running. Okay, there is something here it's missing. You need again to go to the net. Yes or no? 50%. Yes or no? No. No. Okay. Yeah, yes, you go to the net, but they have something. I'll look at the former name. Now it's called Model Zoo. They have pre-trained models that you can take and run it. When you install correctly OpenWINO, they are at least a bit optimistic. The version that they have now as actual, it's I believe third quarter of 2021. We are in the future. They have examples that hold the code, and we're gonna run this. So my advice to you, if you are interested in this, install OpenWINO. It's no problem. You do not need any model. They will get the models. You do not need the GPU. You can work on the PC without problem. See what's up. And this is what we're gonna do now to see a bit difference how it behaves. I took the barrier example, and we'll get back to see how some techniques of optimization could be applied to this. And I put more pictures. And we're going to run it, let's say, twice to see if the stuff is changing. Twice on CPU, which is an i5, and then twice on this. and to try to see take something to write, to see what are the difference in the floating point stuff. What can I, not floating point, GPS. We'll see when it started. What can I tell you? That the examples are wonderful. They are built like a Rube Goldberg machine. You have a solution that creates 20 empty solutions, that creates 10 empty solutions, that create 11 CMake files that go to another CMake file. So I pondered if to show you how you can call it, but I'll say that it will be too read. It will be too dry presentation. Now I'm going to show you really the example quite near to the first level. And I can tell you that it's not heavy, but not trivial to call an inference model in C++. This is what we tried. There is a bit of work, but if you don't do it once, you can run OpenWino on everything and anything without issues. I'll say the examples are a bit cheap, but we'll get the idea. Let's do the barrier. So, someplace still alive, because this is the output level. So let's go controls. Yes. The example per se, it's a batch file and a bunch of pictures. And in fact, only one picture, this one. And I modified the batch file to run with several pictures. Let's see it run. It runs, usually you need to have installed Python, they give you all the instruction, and sometimes you need to specify in a set part the path to the CMake. You see that it's 4 streams for CPU, goes for each core. And now we should have someplace. But here it's just saying stuff. Saying stuff like building the CMake files, going to the model zoo, getting the pre-trained model, doing stuff, and creating solutions. Let's say, have the time for 4 runs. I expect to have now, after this, we'll start getting small windows with what he has detected. In fact, it's more the detected local, no, it's detection. Now I do not know why it's so slow. I was going to blame on streaming. Yeah, it is taking process, of course.
Will you open the task manager to see how the processor is crunching on this thing?
System interrupt. Usually, I would say that this is the problem with the, and now it's going to do the first one. You see, 8. Let's try to remember just for the first one. Yeah, 8.2. And you see they detected it's a black car and wrote read the number. Okay, you know I have more chocolates. This is what I'm going to tell you. And I will be the second car, and I'm going to close this. Now it's a bit better version. You see here it's identify as truck. Okay, it's a Skoda, but still not a truck. Let's say also for this 14.6 floating point per second. No, frame per second, sorry. Again, here it detected anything. And you see after they build all the stuff, they just code. That will be what will happen in your code. They just this part. Loading detection model, loading vehicle attributes, this one. Here again, did not detect anything. Here detected the number plate. Please louder.
This is LPR detection.
Yeah. It looks for the car and try to read the number plate. Here I see the number plate on the corner. Yeah, did not detect the car. Again, this is a free model that you get from Model Zoo. Here, this is something to impress your boss. This is the last. Detected the white car again, it's a Skoda. Okay, I try to, let's run it again, to normalize a bit the results. Let's see how much it will get. I try to impress a boss. I get to the parking lot and take pictures of the car without changing the model. What do you believe that was the result? Did it detect any number plate?
Nothing. Anything. Dead.
And you know why?
Because it's not for this plate and not for this country. It's
no, because
it's not trained for these cars.
This is blue. Number plate in China are blue.
And ours is black and white in all Europe Union. So there's a models for all the regional countries.
Let's say for Bulgaria, we know how to do it. If you know who to sell it. So here there is a combination between a sensor and something. It's not, and the bigger problem is on Serbia because they try to push the strange. They have G,
yeah,
and yeah, and Sh, and also we have Sh, but our Sh has a tail, not a hat. But we do not use number plates. So this is still now done again the preparation. Again, I did not change because I'll say this is like a root ball. Now it's a bit better, 7.6. And let's see the next. And for the rest, I'll just close it. Again, I'll tell you if you want to 13.6, a bit better. Before was 14.6, something like 1 frame per second, better. I'll say if you're trying to do recognition, some filtering before it's always helping. And again, this is the difference between the, let's say, the people who know and the people who are new by to it. This is how you impress. Yeah, I did the filtering to make it black and white and stuff. Now it's working much better. So. Okay. As this is running, let's start with dispensing more chocolates. And now, even though I'm Romanian and I'm bribable, Mikhail did not bribe me to give you chocolates to eat less. So, the chip inside this is called how?
Blue something.
No, but you get a chocolate.
Oh my.
Now it's myriad. Anyhow, I can tell you how this stuff was called before. It was called Movidius. Why? Because the guy, I said the guy robbing the train truck. It's called Mureșanu Video. So it was his name. Of course, Intel changed it. It's in neural stick number 2. And as because today we're talking about open wine, what's the difference between Intel Movidius, so neural stick 1 and neural stick 2? And we're talking today about open wine.
The density of the
hardware.
The hardware.
Of course, the hardware is different. We're talking about open wine. Okay, let's try to reformulate.
No, this is a single hardware. What's more hardware support?
Intel Movidius supports open vinyl.
Yeah.
No,
Maybe
no,
not.
they
No.
have a difference in the time. They can't support it.
Open Wine supports.
No, the first version, Movidius, did not support OpenWino because it wasn't bought by Intel. And they did not see any benefit at that time. And when Intel bought all the shop in Timisoara, they said, okay, let's get it into the herd. So they redesign, clean up the hardware because, of course, a small startup from Romania does not know as much as doing buffers and stuff like Intel. And afterwards they say, okay, we need to support OpenWino. Inside the processor is called Myriad. Okay, put it in. And name another product from Microsoft, new, you cannot get in Europe, which is using the Myriad processor and also supports OpenWino. Of course, it's starting with what's Microsoft selling these days? It's not Windows.
It's Xbox. No, I have enough for the others.
Okay. In Xbox, they are making money on it. They don't sell. You don't see Sofia saying Xbox. It's Asia. Of course, it's Asia. They are selling, which is a very nice stuff. They have two versions: Percept Vision, which is using for analyzing images, computer vision, and one Azure Percept for sound. Azure Percept Vision. Maybe I got the name right, Vision, but there are two, one for sound, one for image. Supports has on it a Myriad processor. So you can run OpenWino against it. And I do hope that the next presentation we'll have with the Percept on the table. Look around it. Unfortunately, it's very hard to get into Europe. I'm trying very hard to get my hands on them. Everybody wants them. And there are especially only for you, very rapidly accelerate hardware development. This is for making prototype boards and then expand this. And also they have the Azure services behind it to do it. So we put this. How do we specify this to run? Okay, here you see, unfortunately, it's far easier. It's -D, I said CPU. If I don't specify anything, we run still on CPU. Let's see if I get it right. If I got it right,
it should run on the blue stick. It should run on the blue stick with this argument.
If it's wrong, we'll get to run again on the processor. And also we can look here inside of the file because they explain. Let's get it on the Notepad++. Today. So let's try to make it a bit bigger this time. The Windows So these are what's acceptable: CPU, GPU, FPGA, RTDL, and Myriad. GPU, I have a very strange laptop. I have an NVIDIA and Intel board. Doesn't work on mine. Okay, let's get rid of Windows. So let's run it. I believe that I wrote it correctly. And this will do, again, this part in real world case will be done only once. Again, I did not modify the examples dramatically, just add more images. So it's something that you can try back home even now. Everything is free. I believe that maybe you need to register. And also it's powerful. And this toy, what's the advantage of this toy? You can do very complex computer vision on junk like Raspberry Pi. Raspberry Pi is not junk, but it's really not industrial, does not have the power of running it. And you'll see that even on this, we'll see some differences. This is why I wrote down this. This is really done for inference.
What is the price on the stick?
Yeah, it's and you find it on Farnell. Okay.
Yeah, the Bulgarians are better than the Romanian. I have problem delivering Amazon. And what's the funny part? I asked from Intel in Timișoara, where they're building them, to give me some engineering models to show. And they say, we have none for you. And this I got from the States. Politics. No politics. You say, okay, we do not have the time of, let's see. Here you see, loading device, it's myriad before it was CPU. So, 14.4, and before it was 8.2, 7.6. And this is an Intel i5.
Twice as the previous those.
Yes. And you'll get the same results on a Raspberry Pi. On anything hardware that can run this. And also you can run them in pairs. They run in parallel. But remember one stuff, this is only for inference, not for training. For training, you're getting to Amazon, to Google, to whatever to train, where you have processors. And when you have the images, this is 23, and before was 14 or 13. And we're still in good time. To my great amazement, so I'll take a sip of water. I really like to drink water when I have a mic, and that is the best sounds in the world. I did a lot of trainings as an MCP this pandemic, and it was really a pain in the backside trying to get some water. This again, it's faster. You see that the results are consistent. You got the same results as before, but much faster. And we are starting from the same model. Same model, we are just running to a smarter hardware done for computer vision. Again, what I'm telling you, OpenVINO, it's the lazy man in the way. You find the model from someplace, or going from the zoo, you'll get it optimized without knowing shit from elbow to run faster and run it on everything without changing the code. So it's an option. And also, if Microsoft saw them as an option for Azure Percept, it will be something. Okay, the guy who's doing that, it's let's say electronic geek. I've had been to all makers fair all over the world, but nevertheless, it's an interesting product, and they see value in OpenVINO. So again, once more in the bridge, run it once again, and we'll do a small wrap-up with some nice graphic on like any business presentations. And I can send you my bank account to put the rest. If you want to take, it would be hard luck. But also now we're having a European project, because the main professional of milking them in agriculture, and I changed the technical proposition to use OpenVINO on all the stuff because we want to see. Okay, it's not politically correct to look if the trees had been cut, because in Romania they disappear. But if you want to see if the crops have enough water, and want to do a model, of course, very lazy, to see if the watering is enough. And we're going to use this. I'm not sure if we're going to use neural sticks, but who knows? And this, let's run again. And let's see if it gets a bit better. Now, usually if it gets better, this is because the transmission to in Windows has got better. You won't see that big differences. And now we're going to see big differences, because I tell you that you won't see any big differences if you're using the neural stick, because there everything is happening on the stick. And as a rule of the thumb, if you want to measure something, do several runs and try to do an average, not to eliminate the edge cases. So being a conclusion. Again, OpenVINO technology from Intel, free to use. If you live in China, you're gonna impress your boss quite rapidly, showing the number plate recognition and stuff like this. Otherwise, you need to train your own model. You can use any, you can take any model from the net. And also they have a pledge of making the intermediate layer know new models. If a new model goes on the market, they will try to get it and do it, be able to do a transformation to intermediate layer. So it has some future. Okay, 15, this is now better. A bit, but not much. You are still in the same ballpark. And the second one. And afterwards, we'll let it run. I'll show you us running some other benchmarks. Neural stick, it's not the only product. NVIDIA has something at this kind of size. Okay, what they do not have NVIDIA, they do not have OpenVINO. I said OpenVINO is a solution, any model to any hardware. And this helps you doing stuff. Okay, so getting back to that would be some benchmarks. I'll try to make it a bit bigger. 150. They use as a rig. I believe the price of this is an old one. They use the Raspberry Pi. Raspberry Pi trying to do inferences and stuff like this. The biggest, best results, unfortunately, I cannot make bigger just the image. I'll try to take on it. Let's see. Yeah, it's working. Guys, what? Anyhow, you find it. This is from Huckster.io. Usually, how much you pay in the hardware, you get the results. And using Neural Stick version 2, it's a way of doing a cheaper hardware solution. Also, I'll say, with OpenVINO, you have the liberty of exploring. So I'm doing my solution with the Raspberry Pi and Neural Stick and the camera. And then we move to a PC with a camera. And we do not need to change the code, and we use the same models. And also for the solution with the screws, this is how we started. We first evaluated with the Raspberry Pi. And afterwards, in an industrial environment, we said, okay, they still have a PC there, a PCB. So let's put a camera to it and run the model on top. And it works. I would say the customer is highly. And for us, it was, let's say, a weekend of fun, beer and programming. What can go wrong? So, and we got more work because of it. Anyhow, we needed more money, not more work, but and pretty much, yeah. So, if you have questions, I have 3 chocolates to give.
When will you prefer to use NVIDIA GPU instead of in which cases would it be beneficial to use the NVIDIA GPU accelerator?
Let's put it this way: if I really need the performance and if it delivers, because I really need to work with NVIDIA. Here I can work with everything. I don't care. This is the liberty. I hope that answers your question. That's one. We are lazy. Other questions? Still, 2 chocolates to go. Okay, so I give you chocolates and one. One for you. And if you have more questions, I'll be around. Also, you can, I'll give you my contact. And unfortunately, it's absolutely funny. For the last years, I wasn't able to move my blog because the technology moved that fast. When I start writing something, a presentation, I can do it much faster because if I have the demo running, I can change the text. If I'm writing the text and I'm getting peer review because I don't like to make myself a fool in writing, I'm usually more mad or natural. So the problem, I'm not sure what we're going to do with the blog. But if you write me, drop me an email or find me on LinkedIn, I'll always reply. Also, let's put it this way. All the titles I got it because of interaction, because of you. Thank you very much. And I'll say, I'm around. Try it. It's interesting. You can impress a boss with it. Number plate recognition is not the only stuff in the models. You can. It's a way of getting budget. We got budget showing something like this. And it's the time for lunch. Thank you very much. Have a nice day.
These days, if you don't have an app, you're falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
Start my days, sun rays, I tap the phone, coffee's on, I mow the lawn, impressing Sean, so connected, so effective, I let it drop, clean it up, heat and smart, I do my part, get in the car, superstar, they're watching me, IoT, IoT, IoT. IoT, I check my stock. What a shock. Buy some prawn. My oven's on. Coming home. Future zone. All for me. IoT. 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 like a Bosch, with many connectivity solutions for a smarter future. From Bosch.
Независимо от работата от разстояние, в MentorMate продължихме да бъдем свързани. Работим от офиса, от вкъщи, от всяка точка на света. Това вече е ежедневие. За да отговорим на нуждите на всеки, създадохме 3 модела на работа, от които всеки в компанията може да избира и след края на пандемията. Първия вариант е комбинация от работа от вкъщи и работа в офиса. Комфортът на собствения ви дом ще бъде съчетан с социалните контакти в офиса. Може да предпочетете да работите изцяло от вкъщи, като ще имате опционално място в офиса след предварителна заявка. Искате изцяло гъвкава и дистанционна работа? Може да работите от всяка точка на света, гарантирайки си по-високи доходи. За да осъществим тези модели на работа, ще инвестираме $1 милион в висококачествено техническо оборудване, което да даде възможност на всеки да работи комфортно, независимо къде се намира. Придобивките за хората в компанията също стават гъвкави, като всеки ще може да избира най-удобните за себе си. Като компания, която цени служителите си, даваме възможност сами да избирате. Тези модели на работа важат за всички отворени позиции и не са ограничени за времето в пандемия. Посетете нашата кариерна страница mentormate.com/bg/careers и вижте отворените ни позиции.
Do you know how to become a technical lead? Well, we have the answer for you. It's MentorMate Technical Lead Accelerator. It's a one-month training program for senior developers of any technology, which will help you build your leadership skills, give you access to a variety of trainings,
as well as a personal budget of 1024 BGM,
and a personal mentor that will help you along the way. Sounds intriguing? Then apply from the link below.
Start my days, sun rays, I tap the phone, coffee's on, I mow the lawn, and Chris and Sean. So connected, so effective. I let it drop, clean it up. Heat and smart, I do my part. Get in the car. Superstar, they're watching me. IoT, 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 IoT. I check my stock. What a shock. Buy some prawn. My oven's on. Coming home. Future zone. All for me. IoT, 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 IoT. Live like a Bosch, with many connectivity solutions for a smarter future. From Bosch.
These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one. These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
I start my days, sun rays. I tap the phone, coffee's on. I mow the lawn, impressing Sean. So connected, so effective. I let it drop, clean it up. Heat and smart, I do my part. Get in the car. Superstar, they're watching me. IoT, 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 IoT. I check my stock. What a shock. Buy some prawn. My oven's on. Coming home. Future zone. All for me. IoT, 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 IoT. Live like a Bosch, with many connectivity solutions for a smarter future. From Bosch.
Независимо от работата от разстояние, в MentorMate продължихме да бъдем свързани. Работим от офиса, от вкъщи, от всяка точка на света. Това вече е ежедневие. За да отговорим на нуждите на всеки, създадохме 3 модела на работа, от които всеки в компанията може да избира и след края на пандемията. Първият вариант е комбинация от работа от вкъщи и работа в офиса. Комфортът на собствения ви дом ще бъде съчетан с социалните контакти в офиса. Може да предпочетете да работите изцяло от вкъщи, като ще имате опционално място в офиса след предварителна заявка. Искате изцяло гъвкава и дистанционна работа? Може да работите от всяка точка на света, гарантирайки си по-високи доходи. За да осъществим тези модели на работа, ще инвестираме $1 милион в висококачествено техническо оборудване, което да даде възможност на всеки да работи комфортно, независимо къде се намира. Придобивките за хората в компанията също стават гъвкави, като всеки ще може да избира най-удобните за себе си. Като компания, която цени служителите си, даваме възможност сами да избирате Тези модели на работа важат за всички отворени позиции и не са ограничени за времето в пандемия. Посетете нашата кариерна страница mentormate.com/bg/careers и вижте отворените ни позиции.
Do you know how to become a technical lead? Well, we have the answer for you. It's MentorMate Technical Lead Accelerator. It's a one-month training program for senior developers of any technology, which will help you build your leadership skills, give you access to a variety of trainings,
as well as a personal budget of 1024 BGN,
and a personal mentor that will help you along the way. Sounds intriguing? Then apply from the link below.
Start my days, sun rays. I tap the phone, coffee's on. I mow the lawn, impressing Sean. So connected, so effective. I let it drop, clean it up. Heating smart, I do my part. Get in the car. Superstar, they're watching me. IoT, IoT, IoT. IoT, IoT, I check my stock, what a shock, buy some prawn, my oven's on, coming home, future zone, all for me, IoT, 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 IoT. Live like a Bosch, with many connectivity solutions for a smarter future. From Bosch.
These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one. These days, if you don't have an app, you're falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
I start my days, sun rays. I tap the phone, coffee's on. I mow the lawn, impressing Sean. So connected, so effective. I let it drop, clean it up. Heat and smart, I do my part. Get in the car. Superstar, they're watching me. IoT, 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 IoT. I check my stock. What a shock. Buy some prawn. My oven's on. Coming home. Future zone. All for me. IoT, 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 IoT. Live like a Bosch, with many connectivity solutions for a smarter future. From Bosch.
Независимо от работата от разстояние, в MentorMate продължихме да бъдем свързани. Работим от офиса, от вкъщи, от всяка точка на света. Това вече е ежедневие. За да отговорим на нуждите на всеки, създадохме 3 модела на работа, от които всеки в компанията може да избира и след края на пандемията. Първия вариант е комбинация от работа от вкъщи и работа в офиса. Комфортът на собствения ви дом ще бъде съчетан с социалните контакти в офиса. Може да предпочетете да работите изцяло от вкъщи, като ще имате опционално място в офиса след предварителна заявка. Искате изцяло гъвкава и дистанционна работа? Може да работите от всяка точка на света, гарантирайки си по-високи доходи. За да осъществим тези модели на работа, ще инвестираме $1 милион в висококачествено техническо оборудване, което да даде възможност на всеки да работи комфортно, независимо къде се намира. Придобивките за хората в компанията също стават гъвкави, като всеки ще може да избира най-удобните за себе си. Като компания, която цени служителите си, даваме възможност сами да избирате. Тези модели на работа важат за всички отворени позиции и не са ограничени за времето в пандемия. Посетете нашата кариерна страница mentormate.com/bg/careers и вижте отворените ни позиции.
Do you know how to become a technical lead? Well, we have the answer for you. It's MentorMate Technical Lead Accelerator. It's a one-month training program for senior developers of any technology, which will help you build your leadership skills, give you access to a variety of trainings,
as well as a personal budget of 1,024 BGN,
and a personal mentor that will help you along the way. Sounds intriguing? Then apply from the link below.
Start my days, sun rays. I tap the phone, coffee's on. I mow the lawn, impressing Sean. So connected, so effective. I let it drop, clean it up. Heat and smart, I do my part. Get in the car. Superstar, they're watching me. IoT, IoT, IoT. IoT, IoT, I check my stock, what a shock, buy some prawn, my oven's on, coming home, future zone, all for me, IoT, 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 IoT. Live like a Bosch, with many connectivity solutions for a smarter future. From Bosch.
These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one. These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
start my days. Sun rays, I tap the phone. Coffee's on, I mow the lawn. Impressing Sean, so connected, so effective. I let it drop, clean it up. Heating smart, I do my part. Get in the car. Superstar, they're watching me. IoT, 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 IoT. I check my stock. What a shock. Buy some prawn. My oven's on. Coming home. Future zone. All for me. IoT, 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 IoT. Live like a Bosch, with many connectivity solutions for a smarter future. From Bosch.
Независимо от работата от разстояние, в MentorMate продължихме да бъдем свързани. Работим от офиса, от вкъщи, от всяка точка на света. Това вече е ежедневие. За да отговорим на нуждите на всеки, създадохме 3 модела на работа, от които всеки в компанията може да избира и след края на пандемията. Първия вариант е комбинация от работа от вкъщи и работа в офиса. Комфортът на собствения ви дом ще бъде съчетан с социалните контакти в офиса. Може да предпочетете да работите изцяло от вкъщи, като ще имате опционално място в офиса след предварителна заявка. Искате изцяло гъвкава и дистанционна работа? Може да работите от всяка точка на света, гарантирайки си по-високи доходи. За да осъществим тези модели на работа, ще инвестираме $1 милион в висококачествено техническо оборудване, което да даде възможност на всеки да работи комфортно, независимо къде се намира. Придобивките за хората в компанията също стават гъвкави, като всеки ще може да избира най-удобните за себе си. Като компания, която цени служителите си, даваме възможност сами да избирате. Тези модели на работа важат за всички отворени позиции и не са ограничени за времето в пандемия. Посетете нашата кариерна страница mentormate.com/bg/careers и вижте отворените ни позиции.
Okay, hello everyone. It's been a pleasure to stand on this stage. I'm the youngest one, so it was really nice lectures before me. I really like AI, but uh, the most valuable thing for me is always hardware. I'm a hardware guy. So today I will show you a lot of interesting things. I will talk about smart business buildings, and of course, this event wouldn't be possible without our partners and our sponsors. Thank you. So first the agenda, and then I will present myself. So who we are and what we do into the topic for today. So we will see what we will step in. Technology stack, I divided this into parts, hardware and software, because I don't know who's listening and what's the interest of the auditorium. The architecture of the control application, we will see later on what is this. Everything is open source. We will divide the products that we're doing into few parts, hardware, embedded part, and into the cloud. We're not including the users because we can do a separate meeting for this. The most important thing for me will be a walk through the code because we all know that there's a lot of technologies, but what I want to show you today is how we built our code, why this way, and how we're organizing the project. As a lead engineer in the software part, I try to get all the best practices that I've been learning since the time of now. And we'll try some demos. I'm really inspired with the Catalan's lectures because he's always bringing hardware. So today I decided to bring hardware. Also, last year I bring a few robots. So today not much hardware, but really important for the project. And of course, question and answers. I would like to tell you not to bother to interrupt me and ask questions. It's really important for me to have a dialogue with the auditory. So please, if you want to ask me something, especially into the diagrams and the code, just stop me and ask whatever you want. This will be easiest way to interact with each other. So onto the track. This is me. I'm engineer. I'm graduate engineer. 10 years from now. I'm hardware and software developer actually, so we can also call it a full stack developer. More than 10 years in the field of robotics. This is the only thing that drives me because it's interdisciplinary. You can see there math, chemistry, physics, electronics, programming, everything. So it's like a small world into the world. 8 years in industrial hardware. This is because my career starts into the factories in Gabrovo, Dimitrovgrad, Veliktornovo, and all over the country. And the last thing is 10 years of freelancing lecturing because I really like to see others' experience, and I saw that I'm getting good when showing what I'm doing to the people. I'm receiving feedbacks and so on, which was really important for me, my career, and my personal development. This is our company, Polygon team. We're a small, compact team. I like big companies, but when you're a small team, you're really fast between the things. More than 6 years into the market, building a custom products for other brands and companies. So you came up with an idea. We built together requirements, and then we came up with a product together with the customer. Of course, we are owning we own some products, but they're in a really specialized businesses. So I'm not focusing today on this thing. This is our partner, BCVT, or Business Center Veliktornovo. This is a brand new building into our town, which is onto the west end of the city. This is maybe will be one of the most automated buildings into the country, maybe. We saw a lot of buildings here in Sofia that are automated, but they're not really automated in the way that the project manager and the project owner see it. So this is not our project. We was invited, and we're really glad because we learn a lot of things, and maybe we will learn much more. We don't know. We stop predicting things because this project is really big. It's really complex. This is the web page. If you're in Bulgaria, it will open in Bulgarian, so you have to change the language. It's most business building, like here into the tech park. It will be used from other businesses, and it will give people ability to host big companies. Our town, it's not a city. Literally, it's not a city; it's a town. Our town cannot host a company greater than 100 people. So, if you want to grow up in a small town, to grow up the town, you cannot sit anywhere. These people, neither with their families. We don't have enough kindergartens, school places, parking places. We don't have enough places to accommodate these people. If we host, for example, 300 people with their lives, imagine what their wives where do they where they will work. This is more than 600 people plus for start, and imagine this thing is more than 40,000 square meters big. This is big building, and our city will grow up. Our town will grow up because of this. So this is a great step, and we was invited to help to build the automation system of this building. So this is the building. It has a lot of sensors. I prepare some helps here. Sorry that I'm turning, but my screen, I don't see my screen. It's black. More than 1,000 sensors, 500 actuators, several servers. We have a separate data center that will hosting all the servers. We are prepared to host a bank server. So this is a great building. We have 5 internet service providers and 3 power service providers. This means that if the town have a full blackout, the building will still be up and running, which is really important. We have a diesel power, 2 power stations nearby, 3 substations, 5 trusses with fiber optics, and so on. So these numbers mean that on each window you have more than 3 sensors for everything. Look how much there is. It's not even a skyscraper. This is a small building, but there's a lot of equipment inside, and it's really impressive the size of the technical things that we should work with. So maybe I should explain what's going on. If you have this kind of building, you need some system to operate. You need to handle access control. You need to handle destination control. You need to handle security of every single office. You need to handle every opened window. You need to handle every single sensor for smoke, lights, and so on, because this building will be green. It's really power efficient. There is a great HVAC system inside that will produce heat energy. On the first lecture, you saw that the lecturer said that they train a model how to optimize the power, energy consumption, and how to keep water really warm or hot. It depends on the needs of the client. So their training model here will be the same. We have 3 machines that are producing heat, around 1 megawatt of heat power, a lot of heat exchangers. We have 14 kilometers of tubes into the ground to use ground thermal energy. It's really nice thing. I love it. This is my greatest project at all, and this will be the challenge of everything. It's the ultimate challenge for me. So part of the technology stack. This is the hardware used, mostly NFC, because it's safer. It's got a lot of features inside to store information into the smart cards. to check information between the cards. It's really secure. If you want someone create main in the middle with a separate antenna, we should be aware that this thing could happen. So that's why I'm talking about this. This cards enables to secure them and really fast enable disable them in case of a problem. They're used because they're accessible from the several points of view into the system. The first one is it's a smart card. You can store things. The second one is the card readers. They're much safer and much robust than the normal RFID. Evaluation destination control is a lot safer because imagine if you don't want anyone to go into your floor, into your office, because there may be companies that will require a whole floor of the building. We talk about big clients after all, so we need to keep their security and everything. So that's why we have destination control. So imagine if you're my guest and you didn't require an access, you cannot enter even to the floor, which is really important for us. The access control is something that could be used not only for the doors, but for the swimming pool, the fitness, restaurant. So it's like a digital identity to the person who owns this card. You can load credit into the building and you can use it to exchange it for separate services, and everything's going. It's really easy to work with these things. And the most important thing that it's a comfort feature of the building, that this is a profiling. So you enter into the building knows you. Otherwise, we will use a facial fractal reconstruction and detection. But as we all know, with EU, we have GDPR and all sorts of things that are not letting us to use a facial recognition. So we will use a card. It's the same, but it's not part of your body. Wherever here. So you enter into the building. The building open the first door. It starts to warming the office because it's winter. It's calling the elevator for you, and when you go there, the elevator just open the doors. You enter into the elevator and you go to your warm, lightened office. So you don't need anymore to flap the switch, to hit the button to call, to wait for the elevator. There will be 6 programmable elevators. It's something that we know here in the modern business buildings in Sofia. This will be the first kind of elevators in Victor Mall. Yes?
I have a question. When you say your profiling, does that mean you're going to remember what temperatures people choose and use those temperatures in the future as default setting for them?
So the question was, will the building remember the profile about the temperature, lighting, and accessing different zones for the separate user? Yes, the answer is yes. And most important thing, if you're a company, and for example, you're 7 women working there and 3 men, our modeling shows that the women would like the rooms to be warmer than the men. So when more women came in, the temperature will rise maybe with a degree. The women will feel comfortable, and this will create an environment that is more suitable for this separate company. So we know everyone house profiling, who's accessing, when is accessing, and we're doing this not to collect the information, but to create the comfort profile like the modern vehicles do. So this is the most important part, and that's why we use NFC, because it let us to secure everything, because the security is really important for this. The other important thing is that the building know how much air you consume. One important feature is how to exchange heat energy between used air and the fresh air, because when you enter into the room, one of the things that is going to happen is the ventilation will run automatically. Because if you're standing inside, you will be like Darth Vader. And that's why the building knows how much air to let. And in case there's no one into the room, it's shut down the lights, locking the door, closing the valves of the warm water, closing the valves of the cold water, stopping the ventilation and closing the valves. So nothing will go into the room or outside the room. It's basically like a container. It's really nice thing. The building is so smart that it knows where is in the ground, the surface of the earth. It knows where's the moon and the sun, calculates the sunspot onto the floor, and calculate how to run the shutters, because you can use the rooms like a heat exchangers. For example, it's Saturday and no one's into the building. We open the shutters, we run the cool water into the building, and the heat are taken from the rooms and put it into the ground. So on the next day we can use it to warm something. And when the price of the electricity goes lower, we switch on the electrical boilers and continuous heating water to use it on one day. No problem. So if you don't want to exchange, to be a part of this heat exchanger, when the sunspot on the ground lets more than 1 meter inside, it closes the shutters like this, because one of the problems, as you all know, people who work to computer, is that this direct sunlight hitting your eyes is not good, and hitting your screen, which is also not very productive. The most important ways, not the ways, but the most when you want to read something, you have a page of paper and you need more light to see it. You open the shutters or you switch on the lights. It doesn't matter. It stands there for 5 to 20 minutes. It depends on the trained model, and then it will glow again to get around 1,500 lux to create enough light you to work, but not much to get light around the page. So this is one of the comfort cycles, because we saw in our models that people are using lights only to see or read something, and this process starts and ends, and there's a time for this, but not all day. You don't use lights all day. So here into the conference hall, you can see that the lights are dimmed. So it's enough to see each other, but not much. And the shutters are closed. So this thing, you can say to the room, this is a presentation room. So made a profile for presentation. You hit the switch and everything gets prepared like this way. Of course, there's a lot of actuators and sensors that are responsible for all these things. And they're using technology that is 40-year-old, and it's called Modbus. Modbus is industrial standard used for field bus data exchange protocol, and this protocol is good to say switch on the light, what's the temperature of the sensor, tell to the fan to work at 50%, and so on. So this is the control information. It's very good to number transport. So we use it for general purpose I/O, locking mechanisms, relays, locking mechanisms into the doors of the drain change rooms, and stuff like this. Lights are controlled by 0-10 volt circuits. They are again controlled by Modbus. There's specialized electronic board, that's telling the lights to create a fade effect from the windows to the depth part of the room. This means that the lights on that side will be much more extensive than on this side, because there's the windows. And if you take the lux meter, you will see that the luxes on all points of the room will be the same. This creates really nice space to work, and it's really comfortable actually. Humidity and temperature are essential for the HVAC systems, ventilation, heating, and air conditioning. So that's why we have several sensors into one room. Air that is coming from the cleaning part, air that is drained from used air from the room and the general room temperature. This is really important to create a temperature control model. Signals. There's a lot of signals. For example, if you hit the door, the signal come out. If you open the door, the signal come out. If you open the window, the signal come out. If you move into the room, the signal will come out. And all these signals are used to create a state and equations to control the environment. For example, if 1 hour later than usage of the room, there's no one, even if it is on working time, the room will enter into the green mode. It will shut down the lights. It will shut down the ventilation and heating or cooling. So everything will be stopped. Of course, shutters will close also. And this means that the room is not used anymore until later 1 hour from now. The one important, it's not important, but it's a really nice feature. I like it. The doors have windows, and those windows are blinded. They're blurred. And if you give a card that are accepted from the system, the windows will become transparent. So it's really cool feature. I like it a lot. It's like a spaceship inside. And the security, of course, we have signals from separate systems like antivirus system. When the antivirus system, it works separate from the control of the building, because it's a mission critical system, as we all know. The fire is not good thing, and the system signals the ERP system that controls the building and say, okay, we have a fire, do something. And what you could do, you can stop ventilation, you can stop heating, you can stop water, you can stop electricity, and you can close all the air valves in case of re-airing the rooms, because we all know that the fresh air will increase the fire and results of it. So that's about the technology stack. There's a lot of different vendors and producers of hardware. We create a separate hardware layer. It's called HAL, hardware abstraction layer, to create a compatibility between various vendors. But later on, when I'm showing the code, you will see this thing into detail. So this is the technology stack of the software. It's really common. There's nothing that you haven't seen yet, but it's a good recipe for this kind of task. We use Debian as a base operating system into the controller. So our controllers are basically small computers. We use Visual Studio Code because all of our software is written in Python, as you see. Flask for the small separate services. You know, the big companies are using a design pattern called service microservice, and all the functions are communicating to each other via HTTP. So that's why I use Flask and URL and requests. That this thing led us to create a really nice communication layer between the controllers, the ERP system, and the other hardware that are not was not part of the system yet. The Modbus, we say a lot for it. The NFC is essential also for the access control profiling and destination. And the next thing is to show you how actually the application is working. I saw the other lectures had really nice slides. It's really important for me to show you how this thing works in practice. So I will go to the screen and show you how this thing works actually. So first things first, this is the main loop. We all know that all applications that would like to stay alive inside the cycle of the operating systems have a main loop that let the operating systems give them a runtime slices between the other processes. One of the important things that we should mark is that we are not real time, because we're not controlling mission critical things. So if we, for example, freeze, we can always reboot and the other important thing is that we're planning to boot over the air, which means that the controllers are born without operating system and without anything inside the flash. They only know where to take the image and run it on themselves. So this is the main loop. The main loop are running the ERP communicator. It's a simple HTTP client that authorize the controller to work together with the systems. We all know that there might be scripts or attacks that would like to take over the control from the ERP and to receive the credentials to control and merge things from the system. So that's why we have a login. It's really important for controller to log in a proper way, otherwise it won't work. It will create big tables with non-user devices that will later on the system will say, okay, this is an attack, and will filter all the attacks that occurred inside the communication block. So this is important because we all know that physical security is really important for one computer network, but there's guys with screws and instruments that can do a lot of bad things. So next thing is to give a runtime into the plugin manager. The plugin manager is a thing into the system that sees all the functionalities. So we have lights, we have shutters, we have door access control, control of the heat production, controlling the distribution of heat energy, and so on and so on. Every group of functions related to this thing can be called a business logic. And all classes of these business logics can be divided not by subclasses, but divided by separate modules. And every module can be called a plugin. All the plugins are implementing a interface that that plugin manager provides. And this interface lets the plugins to have a runtime. Of course, we can load on multiple plugins. Of course, we all should be aware that when plugins working together, they are sharing the same hardware interface that is provided by the controller manager. Only single controller can be loaded at a time. This means that every single control zone can work with only one PLC at a time. Of course, the PLC can be represented by multiple cabinets of electronics inside. It doesn't matter, but it's a single PLC, and they're sharing hardware resources. This means that if you give the digital output 1 to the door and digital output 1 for the different function for the lights, for example, the error will occur, and of course, no runtime will be given to these two plugins, because otherwise you can create signals that are not proper or cause a fire or unexpected behavior inside the building, which can cause more damages, which is not suitable for our case. That's why we have a security system that all the hardware resource before to go inside the PLC, because the PLC is not really clever. It's actually executing commands for the digital and analog IOs. So we should be secure here. When the business logic is running, it's a digital. You all know that the digital computers work with the time slices. So all the algorithms for controlling things are given a small part of time that do their job on a single time. It's not again real time. We cannot determine how much time this plugin, or this plugin will consume. But what we can do is to say, okay, we will update on every half of the second, which means that all the time that will be consumed from this plugins can be only half of the second. So we can in software way, we can say that this system is real time, but it's not guaranteed, because the kernel that we are using are not patched, which is not a problem. Okay, so next to the hardware interface. The hardware interface in our case can be Modbus, but this is for this building, for this separate project. This thing will live maybe longer than anything that we build. So this means that this interface can be changed. From this point of time, we are controlling three separate things. A smart island, there it has a digital input outputs, analog input outputs, interrupts, and so on. It letting us to communicate with the signals from the physical world. A sensor that can sense various things like movement, light, temperature, and humidity, and of course actuators, shutters, door locking mechanism, valves for the distribution of heat energy, and so on. And after all, the real world is come where we work and interact with the system. So that was all about the theory of the plugin and the system. If you have any questions, if you're architects and you're seeing problems, please let us know. It is time to see what's going on inside the code. I'm opening the Visual Studio, and as you all know, do you see it well? How about now? Better? If it's not better, maybe you can sit closer to me. We're not in class. I'm not taking an exam with you, so please come closer, my son. So, as a Python developer, I'm trying to be better every day and to create files and maintainable structures that are understandable for other colleagues or new colleagues or colleagues that are not in our company, because the project that you see here is open source. Of course, we start with the interpreter, the encoding of the file, and the permission. I learned from Leon and Abi that if you let something into the GitHub, it doesn't mean it's open source. You have to license it, and you have to understand really well how the licenses are working. Otherwise, you're doing stupid things, and you shouldn't do it anyway. So the next thing is imports of the systems. We're trying to use as much as built-in functions. Because if you have too much external dependencies, too much external problems that you are not maintaining, you have. And if something fails, it's not good for the project. When we import in libraries that we're not writing, we first make investigation under what license they are. Are they working properly? Are they stable? What is the size of their community and how much maintainers do they have? For example, we tried to work with a specialized meter bus a few days ago, but we saw that the library that the providers gave have only 5 maintainers and only 1,000 users, which is not acceptable for a project of this size. For example, the other libraries like Flask, they have more than 50,000, more than 50 maintainers and more than 50,000 users for all kind of reasons. And I'm talking about serious users. I'm not talking about people who making videos on YouTube and saying, okay, this is the way you can use Flask and so on. You know what I'm talking about, right? Yeah, because they try to say to me, I should behave myself when I'm presenting, and I'm trying to behave as much as I can. Okay, so this is the main file. In all the projects that I'm working, trying to have a main file, because I'm a person who can dive and kill itself before I start to work. I need the entry point that all the time is the same, and I'm doing a simple main file that runs everything. Then the second file, of course, is the file that will provide the base functionalities of the application. And because we're zone promat or zone of electronic automation, of course, the first thing that you would like to create is a single zone that you will control. And of course, the files that are holding our zones are called zone. All the files have author, copyright, credits, license, version, maintainer, email, status, and class name. Why? If you have a license, this license is for humans. But if you have a machine crunching for what kind of reason, it doesn't matter, you need the flags that the machines or the out documentation systems will deal with. This is really important for the project. And of course, the file version, you will see that all file versions are version 1. It doesn't matter that we have 100 commits from the start of the project, so we have all version 1, because we're still doing things that is not in release. This is very important to know. We're not in release, we're working more than 2 years. This is basically the first lecture and the first presentation of this technology. I'm really glad that you're here and decide to see our job. Okay, as you know, as we all know from the first lecture, we have a mode. So the system have a mode, and in this mode, we know how much energy we will drain from the electricity or from the earth, and so on. This will help us later on to model the controlling mechanisms. Of course, the next thing is the ERP. ERP have a single abstraction, and it needs two basic things, client and server. The client lets the control application to make calls to ERP, and the server lets the ERP to create a callbacks or webhooks. Because imagine if you load the web application onto the kiosk of the system, because all the rooms, all the zones will have a small TV sets that you can interact with the system. It's like in the movies. You have a display, you interact with it. The display will call to the local server, not to the global. Why? Because maybe someone with a drill hits the cable. And this is a common problem when you have a lot of people around. All sorts of problems are going on. So one of the tasks of this application, when the web application calls some functions into the control circuits, the controller instantly call the ERP system and update the state of the room. This is important for the statistical information and the decision-making algorithms for controlling a heat production, cool production, water consumption, electricity consumption, and all these services that are essential for controlling a single zone or multiple zones. The controllers. As we said, controllers can be different vendors, different models. It can be with much more analog inputs than the previous one, or whatever. So we have a controller interface that let us to implement a different hardware interfaces. So for example, when we go to the demo, you will see that our controlled zone for today is Arduino Mini Pro, which means that it doesn't matter what is the cost of the hardware. It depends only to stand on the interfaces that are given to it. Here in vendors, we can see dummy. Dummy is one we use for tests. Because it's something that we built 4 years ago. It's our first industrial hardware project. UniPi is a blue controller that are made from in Czech Republic. They're really nice controllers. They're with Raspberry Pi inside, so the software can run into the controller and create control mechanisms. And this is a Chinese vendor that are providing part of the hardware, but later on giveaways, I will give links to all these things. So the data is the namespace where we hold all our data structures. Because we are mostly into the control, the only data structure we have is the registers. So what is registers? It's a list of descriptions, how the signal looks like. What are they numbers, are they booleans, are they strings, JSON, and so on. And this is the exchange format between the control applications on format and the ERP system. So there's a single HTTP call from the controller control software to the ERP, and there's the JSONs that are described in these registers. So one register has several properties: name, base name. We have something called namespace. For example, lights dot outputs dot output 1 or dot output 2. This is the two signals that are used to control the lamp fade effect. So base name will give you only the name of the base name of the namespace, and the name will give you the whole name. We have timestamp. The timestamp gave us information which was the last time that this register was updated. The value is the actual value of the register. We have a scope of work. The scope of work said that this register came from the ERP to the controller and from the controller to the ERP, or both ways. On both ways means that the both sides can edit it or modify it. We all know that Python is not really highly typed language, but we have a way to type the register because it's really important how information is handled later on. And the update handlers, because we try to be as much as event-driven we can. We have update handlers that are executing every time when the change occurred into the register. So it's not necessary to pull all the registers all the time. It happened only when the changes occurred. This is this thing are making the system to use less memory and less CPU. The plugin name is the property that show you who plugin owns this register and who is the when the information came from. Description is a text that is readable from the humans and is displayed only in ERP because it's a system software that is not, it doesn't have any user interface from this moment. And of course, range. Range is only used when the register is a number. So if your lamps cannot produce more than 15,000 luxes, this means that if you enter 17,000, it will automatically cut the value because the system cannot deliver as much as you want, and the control algorithms will retry to do things that are impossible in the practice and consume more computer energy. So I know that for a single plugin this sounds stupid, but imagine when the plugins are getting more and more and using more computer energy and more memory, this thing starts to be, you can feel it really well when you're reading the numbers, and that's why we have it. And the limit is of course upper and lower limit. Again, it's number. So this is our only data types that are holding actual information. And this is the devices. The devices are divided into separate categories. Drivers. Drivers are something that is abstract. It's describing information or exchange models. In our case, we only support models for this moment. Factories. Factories, as we all know, are producing things. So what we need: card readers, convectors, fans, heat pumps, light sensors, power analyzers, pumps, thermal sensors, valves, and whatever classified hardware that we have into the system. So like you're going into the warehouse and I need this 3 of these valves, and the factory delivers the valve. So this is really easy when you're implementing new models or new versions or separate vendors, because the things that the software should do are getting less and the speed are increased. The tests, all the hardware have an automated tests. This kind of system is really hard to test because there's a lot of components. Some parts can be unit tested, some parts can be So how the hell you can test the communication between you and the ERP? The only way is when you try to communicate with the ERP, but you cannot produce a failure because you don't know how the workers did the cables inside the walls and so on. So the tests sometimes are cannot be designed really well, and because there's a lot of hardware, most of the tests are actually done manually into laboratory where all that things are simulated in the control environment. Otherwise, we cannot. For example, next week we'll have to put in fire some valves to see what's going on with their silicon enclosures. Are there something wrong can happen to the system, or the people inside are bad gases are released and so on. Utilities are algorithms used inside the devices. They are not like a control algorithms like bit regulators or averaging filters and so on. This is something really specific for the system. The vendors is the namespace where all the vendors are placed. Inside the vendors are models of devices, and inside the model is actual implementation of the drivers of the device. So you can see it by your own. This is vendors from all countries around the world. Plugins. Plugins are these small parts of the business logic that are responsible for separate physical functions. Light, shutters, access control, communication with elevators, communication with heat-producing machines, everything that can be separate as a single function. Of course, as I said before, they are implementing an interface, and this interface is used. I have a template for me from the plugin manager that is responsible to give the runtime of the system. So you register all the handlers, adding the handlers, creating a configuration interface, and load plugin. Basically, one plugin is never loaded into the RAM of the controller if it's not needed. So the system is aware that the files are there, the binaries are there, but they're never loaded. And this is keeping the memory as less as we can, because we all know that memory leaks can occur, and this is really bad for the system, even if it is not real time. We have the structures all over the code to release the memory if we don't use it, because it's more efficient. And if the system scales up, it's scaling every day. If we don't use this kind of practices, the memory will leak too fast, and we should need a control over this process. So this is the listing of the plugins. I will go to the public methods. So this is how the let's update something. So this is all updated plugins. You go through it, update all the plugins. If something goes wrong, you log it, and the logger is responsible to call to the ERP and say, okay, something goes wrong. Call the administrators or call the maintainers. This is the way we can automate the maintenance of the system, because the database behind it's growing like a baby. So this is the way it should be done. It's exactly the same way, because they're sharing the same interface. But of course, most of the people are aware. I will be happy if a junior developer are watching this lecture to see that the things are not really different into the other companies, and so on. This is the services. The services are important. We have a HTTP server, which is a base for the separate business logic that needs HTTP servers. For example, We call it the blue controllers, the Unipy controllers have callbacks. If a GPO for some reason changes state because a signal occurred, like someone opened the door, we have a HTTP server that receives that call and take action inside the plugin. And this happens only if it calls. So in this case, we don't pull all the GPOs all the time. We receive events. And that's why we need an HTTP server. The global error handler is something that is a static class. Most of the people will say, oh, don't use static class. It's good. It's good for things that are not changing quite often into time. This thing are giving a possibility to log all the errors, to know in which plugin what's going on or which part of the system what's going on. And we have error codes that are used machine to dispatch the messages and the separate responsibilities of the maintainers and system administrators. The tests, as I mentioned before, sometimes it can be automated, sometimes it cannot. For example, if you would like to test a plugin, you will need a hardware controller. This is the dummy controller most of the time, and all the signals are logged to create the data diagrams. And to create analysis, does this thing work properly or not? This is a small program that are exporting registers. We have an exchange formats between the systems. This CSV file describes all the possible, for example, states of one register, to which plugin it is, from which side of the system is controlled, default value, and the human readable text that describes the function of this register. And this is the namespace access control. This is the component locking mechanism and its property output. So the output needs to be digital to lock or unlock the system. It doesn't matter, is it a motor that are locking bits or it's electromagnet that hold the door. It doesn't matter, you just need a digital output to work with the system. So this is the most parts of the system. I will not go further in details. I will be happy if someone open our repositories and see what's going on inside. On the takeaways, I will give links to all the things of the system. Maybe some demos are good to see. So I will run the main file and we'll say that yesterday it worked. Okay. Čaramo. Ne. Much better. So Are čovjek? No, I know. Of course, yeah, I'm trying to hit F5, but instead I'm hitting 4. Sorry. What the hell is going on? Maybe don't like to show. I want to see my screen. I feel much better when I see my screen. I cannot see my screen. I don't understand what else. Yeah. Мисля, изобщо не го съм искал backspace през цялото време. Нищо не е мисля. Steph, can you see my screen now? Yeah, okay, and I can see it too. Okay, let's see what's going on onto the log. The first thing, we're loading the controller. This is the controller vector is Power Industries from China, of course. This is the model, Java, and this is the plugins that the system found. Of course, the first thing is to be in idle states, then to initialize all the things, then to try to log into the ERP system, and then to go into the running mode. Then it's running the test HTTP server from the Flask, and then running all the plugins. So I will try to open the door with my test card. This is the door mechanism. The red light are making window unblinded, so it made it transparent, and the green LED show me that the door is unlocked. Let's see. Yeah, okay. It's open. You can see me that I'm entering into the window. So the next thing that I would like to try is to increase the light inside the room. So you're seeing that the lights are starting to glow. The potentiometer that I'm holding is representing the light sensitive sensor. It tells the system what is the how much lux there is on a single point that we would like to measure, and this is the control algorithm. I will display why this number is going on the screen. This is the target. We need 7,500 lux. This means that there's really bright inside our room. This is the input information from the sensor. It's floating because it is potentiometer. This is the error, and this is the output in volts, which means that we don't have any single volts, which means that when you're trying to light up the room, it will start glowing. It will not start like this. One of the requirements from the project owner was to create a really comfort control cycles. Don't interrupt the people that they're using the rooms. Be as gentle as possible to what they do inside. Give them a greater comfort. Because I cannot bring all the hardware, if you see the shutters, they're really gentle following the sun. Our algorithms provides a 0.03% error in the next 6,000 years. Which means that is too much. Okay, of course, I can tell the lights really shut down really fast. How? If it's getting really light inside, they almost instantly will turn down, and if you see the LEDs that are representing, the lamps will soon shut down. They're turning will really turn off on 10 millivolts, which means that soon they will be dead. And you can see it now. Okay, they are. So this was from me. Any questions? Someone? Don't let me stay in the air like this. Yes? Sorry? Really good question. I will answer. The question was, if you want to replace the sensors, some sensors we're calibrating them into the laboratory. We have separate equipment. Have to remove what? No, they're being calibrated from the laboratories. From the production line, they're calibrated. We don't, most of the time we use digital sensors. They are already calibrated from the factory. because most of them they're digital. For example, this is one of the thermometers and one of the humidity meters. They are digital. This is the producer, this is the model, this is the address into the bus. So they are digital. We don't do anything to make them more or better to work. The only sensor that we have analog on this time is the light sensor, and we have a mathematical equation that is placed inside the Python code to compensate their nonlinear parts by exponential equation. So this is not something we don't know about, but it's not something that will stop the system. Of course, there's deviations. If we have deviations into the sensors, because they're really easily replaceable most of the time plug and play, we just replace it with a single technician action because of the demand of the supervising this building. Every process are simplified as much as we can. Otherwise, we will not be efficient. Anyway, anything else? Yes.
You mentioned that you're a hardware guy.
Yes.
Have you any hardware, custom hardware for this building? Have you building custom hardware, or are you using just everything that can communicate with your IoT server?
The most important thing for me is to produce hardware, but when you have this scale of project, we're trying to avoid as much as we can to produce hardware ourselves, because we would like to focus on building the system and not the single part of the system. Of course, we have a resource to do it, but the price is much higher if you're building something by your own, and that's why we're trying to implement it as much as other vendors do. So we're always open at persons who are better than us on building the sensors or actuators or whatever, because we would like to focus to building onto the system. But of course, today you saw that the demo is built by our hands and it's really crafted. We would really like to build our own light sensor because the results from the measurements are really good, but it's not. Maybe it will take more time to build the sensor, and the focus from building the system will take the time. And after all, we have only single time to build the system, not to build all things inside it. We can't build the chillers, we can't build the pumps, we should build the main parts like the ERP, the control application, and so on. The important thing that I don't mention that the ERP system is made from Bulgarians, for Bulgarians, everything's in Bulgarian, and it is produced in Veliko Tarnovo, where the companies are located, and the core of the system, of course. The control application is also done in Veliko Tarnovo, and this is one of the things that we really like, because something big that we all know Bosch, we all know the others, they're building great things. I think that there's a lot of good engineers here that can do the job for Bulgarian projects. I think that we passed the time, and maybe I should stop talking. Thank you all for your time. Thank you that letting me to show you what we do. Thanks to my computer that run the code. I'm sorry that I delete part of it in front of you because I'm playing with the keys, but that's fine. Bye.
Like you were saying, you don't share some.
Oh yes, I will. You should remind me more. This is the links. This is the GitHub repo. This is the GitHub repo that is holding the ERP system. This is the GitHub repo that are holding the control software that I showed into the Visual Studio, the control application. This is the record that are holding the documentation. Here you can see plans, electrical schematics, electronic schematics, PCBs, exports of 3D models, everything that is related to the hardware of the system and its documentation. Here you can see the demo application that is running onto this controller. I try to be as much as precise. It can be used in other industrial purposes. That's why the code that is provisioned there is in really high quality. This is my personal GitHub repo where you can find more about myself, how I think, how I write code, and if you want to know more about me, I think this is the right media for this. This is the website of our company. You can see there our partners, projects, and what we do. And this is my LinkedIn. If someone would like to write me a message or curse me because of my bad presentation, and this is the email that can curse me also. This is that's all that I can give you. And of course, tonight I will be in Kanava. This is the next events that are coming from the organizers. I never been to Data Saturday because I don't know anything about databases. I'm not good at all. Sorry, Ivan, but I'm not good. JS Talks. Something interesting that maybe will be interesting about my person is that my home is automated, but not in Python, but in JavaScript. Because when you're giving solutions to someone, you should be aware of how the different languages and different technologies are compatible to each other. So, for example, all the technologies that are thrown away for that building, I tried by my own in my home, and man, I can do a lot of things. For example, I can play the music from here in Sofia, and if someone is at home for some reason, maybe to steal something, I can play my music to steal it in a better way. Why not? One thing that will be interesting, and of course, someone will say, no, don't tell him this is a security breach. No, I will tell him. If someone wants to enter in your home, it doesn't matter what door you have. My ring bell, I have a button to the door. You want to ring me, right? But you won't. You will tell to the home automation that someone wants to enter. And the camera up front of the door will take a picture of you, will show it to me on my Google Chromecast in the living room, will answer me, do you know this guy? And if I say with my remote control, yes, I know him, the bell will ring and I will go to open the door because he would like to know that there's no computers between me and him. But there is several computers. So this is happening all in JavaScript. I'm not a good programmer at JavaScript. I'm using most of the C and Java standards to writing the code. It's readable, but it's not in really, really high quality. So again, I would like to thank to our sponsors, and we'll see you in Canal. Bye.
These days, if you don't have an app, you're falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
I start my days, sun rays. I tap the phone, coffee's on. I mow the lawn, impressing Sean. So connected, so effective. I let it drop, clean it up. Heated smart, I do my part. Get in the car. Superstar, they're watching me. IoT, 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 IoT. I check my stock. What a shock. Buy some prawn. My oven's on. Coming home. Future zone. All for me. IoT, 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 IoT. Live like a Bosch, with many connectivity solutions for a smarter future. From Bosch.
Независимо от работата от разстояние, в MentorMate продължихме да бъдем свързани. Работим от офиса, от вкъщи, от всяка точка на света. Това вече е ежедневие. За да отговорим на нуждите на всеки, създадохме 3 модела на работа, от които всеки в компанията може да избира и след края на пандемията. Първия вариант е комбинация от работа от вкъщи и работа в офиса. Комфортът на собствения ви дом ще бъде съчетан с социалните контакти в офиса. Може да предпочетете да работите изцяло от вкъщи, като ще имате опционално място в офиса след предварителна заявка. Искате изцяло гъвкава и дистанционна работа? Може да работите от всяка точка на света, гарантирайки си по-високи доходи. За да осъществим тези модели на работа, ще инвестираме $1 милион в висококачествено техническо оборудване, което да даде възможност на всеки да работи комфортно, независимо къде се намира. Придобивките за хората в компанията също стават гъвкави, като всеки ще може да избира най-удобните за себе си. Като компания, която цени служителите си, даваме възможност сами да избирате. Тези модели на работа важат за всички отворени позиции и не са ограничени за времето в пандемия. Посетете нашата кариерна страница mentormate.com/bg/careers и вижте отворените ни позиции.
Okay, so welcome guys. Today my topic is related to the how to integrate Azure DevOps with GitHub and Azure Data Factory. It's a very weird topic because most of you maybe think that it's not related to the I/O and the Internet of Things and the AI. But definitely you're going to have some benefits of what I'm going to show you. First of all, few words about me. I'm Ivan Milowski. I'm working as a lead data engineer at PAM Systems. And it's time to thanks one big thank you to our sponsor about happening this event. And after that, I'm going to show you what is the agenda. I will not try to talk so much. I will try less talking, less slides, more demos, more clicking on the Azure. So first of all, I'm going to introduce you what is the Azure Data Factory. After that, we are going to give a brief overview of what is the continuous integration and continuous delivery. Also, I will show you how you can bind your Azure Data Factory with the GitHub repository, some small overview of the Azure DevOps, and in the end, we are going to talk about how to combine all these services at once. So, first of all, Azure Data Factory. You know that it's the big data world. The raw data is stored in a different relational, non-relational, or blob storages and different kinds of systems. Because the business needs to get the context of this raw data, you need a tool which is going to create this for you. Azure Data Factory is such a tool. If you have some previous experience related to the integration services, then you're going to find some similarities between Azure Data Factory and integration services. What exactly the integration services is? It's a cloud-based data integration service which allows you to orchestrate and also to automate and, of course, to extract, load, or to get data, to transform it, and after that, put it in some of the target servers. It contains something similar like the integration services in the previous version. It contains control flows. Also, you have a data mappings, data flows. In the control flows, you're going to have pipelines, which is the logical structure of the activities. This is where you build your flow. And the activity is something which is doing some unit work. Data sets are references of what kind of data you are going to get. The linked services, it's something like connection managers which are pointing to the different sources. Triggers, it's something which is telling to pipelines when to execute or according to some events how to execute and at what time. Interesting part of the mapping data flows is that there is a source and sink. Source mean I'm getting the data from my source. It could be database, it could be blob storage. The sink is the final target destination that you want to put the transformed data. Transformation tasks, there are lots of. So I won't stop by here and put some details, but just keep in mind that you can do lots of things with the transformations task. Talking about Azure Data Factory, it's quite interesting to mention that we have a continuous integration and continuous delivery. What is the interesting part here? Well, the continuous integration is something which provides the ability of the developers to develop their code on small chunks and continuously to integrate it into the system. For your continuous integration process, you need definitely a version control system which should be bound to it. For the continuous delivery,
this is something which is related to validating to make a validation against the infrastructure of the systems, do some tests, monitoring, and if something of all these things is wrong, that it gives you 100% assurance that the code won't be deployed on your target system. There is a different kind of test, of course, which can build, but at the moment I don't want to stop by here. Just want to continue with all the stuff which are related of these services. As I mentioned, the version control systems are very major part nowadays. One such a version control system is GitHub. You know about it, you heard it, you use it also every day. And the interesting part here is that this version control system, it has integration with the Azure, and especially with the Azure Data Factory. Well, first of all, you know that in GitHub, you're going to have master branch or main branch. It doesn't matter how you're going to call it, but this is the branch. And this is the place where you can store your cleanest code. Also, the developers can create different number of branches. It can be custom. It can be according to some references. It doesn't matter. But the idea is when they do their development in their custom branch, they are going to merge it to the master branch. And this master branch is going to be deployed on the target machine. The interesting part at the moment is related to the ADF publish. This is something which comes from Azure Data Factory. In the ordinary GitHub repository, you won't see such a thing, such a branch like ADF publish. ADF publish is built by default by Azure Data Factory when you have when you publish your pipelines into the GitHub. ADF contains two major files: REM template for factory, which contains JSON. This JSON contains information about all the activities that the pipeline contains, and also the REM template parameters for factory. This is the information which is provided for the all parameters necessary for the pipelines, and they're related to the first template. I'm talking about the REM template for factory. But first of all, let me show you a small demo of how and you can bind your GitHub to your Azure Data Factory. So let me show you what is our case scenario at the moment. And the moment, as you can see, I have three, come on, why Zoom is not working? Okay, so I have three resource groups. Each resource group contains three different activities. For instance, Azure Dev resource group contains one data storage. Also, I have one Dev Azure Data Factory and one Key Vault. Just advice, the best case scenario, and it's the best practice to use a Key Vault in Azure. And in this Key Vault, you need to store all your information and all your secrets. Of course, if you go to the tests, you're going to see that I have the same purposes. I have the same resources here, and also the production resource group is absolutely the same. The only difference is that each of these has some kind of value which give you the distinguish between the all resource groups and all services there. Also, if I open the Azure Storage Explorer, you're going to see that I have these three storage explorers, storage accounts, which contains two blob storages. Each of them contains two blob storages. I have source blob storage. I hope so today to have more information about it. And I have three folders. Each folder contains some kind of data. It's our case is some CSV files. And the target blob storage is empty. The purpose of the pipeline at the moment that I have is to iterate through the source blob storage, iterate through all of these folders and move it or copy it to the target. And in the end of the day, we're gonna have the same folders and same files in the target. So when I open, I'm going back to my dev resource group. And when I open dev Azure Data Factory, just give me a second to load. I will show you something that I have at the moment. So as you can see, I have one pipeline. This pipeline is, this pipeline is something which I got from the Azure templates, and with small modifications, I just aligned it to be for our demo. So what is doing at the moment? At the moment, we have a get metadata, which is checking, do we have any files in our blob storage? After that, we are using for each activity, which gives the ability to iterate to all of the folders in the source. And I have one activity which is binded to the for each activity, which is called copy data. Give me a second to show it. So this activity mainly copy the files from one storage to another blob storage. It's nothing complex, very straightforward, very simple. Also, I have two data sets. One of the data sets is pointing to the source blob storage, and the other one is pointing to the target. Also, I have linked services. The linked services, they give me the ability to go to the key vault. As you can see, I have a key vault linked service who is telling, okay, when I have a key vault activity, I need to go get the secrets, read it, and after that to provide it to the pipeline. Also, I have a blob storage linked service, which is going to tell the Azure where exactly are the files are located. So at the moment, as you can see, I have this small pipeline. Now, something which I want to show you, and also which is related to the Azure and how you can bind your GitHub to Azure. Let's go back to, for instance, our test environment. I will open it again. And here it is. So in the Azure Data Factory, in Azure, as usual, you can use different approaches how you can bind your repository. One of the options are to come here and to click on the repository and to set it up from here. The other opportunity is go when you're creating the Azure Data Factory to set it up from there. So I'll show you how we can go and create our connection to the GitHub. First of all, you have the ability to choose what kind of repository do you want to bind. One is the DevOps, the other one is the GitHub. In our case, I'm going to choose GitHub. After that, you need to put your account for this repository because you need to authenticate against it. So I have changes. In our case, it's going to be the main. Deployed on the different environments according to the Azure Data Factory. So pretty much this is it. In the end, you can click apply and you can move on. But for now, because I don't want to do this, because I already bind it on my developer machine, I don't want to do it on my test. So I'm going to click cancel. When you bind it and when you go to your dev data factory in the upper right corner, as you can see, where is my mouse? I don't know why my Zoom is not working, but anyway, you're going to have, and when you click on it, you're going to see different options that you have at the moment. We are in the main branch. Also, I have a development branch. As you can see, the ADF published branch is gray out, which means that you cannot modify it at all. You have the ability to create a new branch, to create a pull request, or to switch to live mode. What is the difference between the GitHub and the live mode? Well, the thing is that when you do something here and you can publish, it stays here and won't be reflected on the Azure GitHub, repository, and it always stays here. So the best approach when you have such a case is to go back to the GitHub and mainly create some development on your development branches or some other kind of branches. For our go, I will create the following task. I will go and copy or clone our existing pipeline. So when I do that, I'm going to put some fancy name here, and I will, for instance, put it IO demo PM. I don't know. Sounds good. After that, I'm going to put a wait activity. This is something which is small. I want to be simple, and to keep it simple, with the whole idea is just to show you what is the approach, nothing else. I don't want to configure some complex things here. So wait for 1 second. Of course, in the seconds, it's by default 1. So here we are ready. Now, what I need to do, if I go to my repository, and as you can see here, I have 3 different branches. Now, as you mentioned, as I mentioned into the ADF publish branch, we have these 2 files, which are the REM template for factory and the parameters one. If I open the REM template for factory and I go and put IoT, I won't find anything here. Why? Well, because I didn't commit anything at the moment. So how to do this? How to do the commit? How to do the merges? How to do the publish? So first of all, when you make some changes on your Azure Data Factory, it's a good idea, first of all, to save it. Yeah. So after that, you need to go and to create a pull request. So you go to your upper left corner and you click on the create pull request. It automatically transfers you to the GitHub. So it tells you, yeah, you have to create a pull request. Create the pull request. Put some commands if you wish, etc. Create a pull request. After that, it's checking if there are some conflicts. If there are some conflicts, definitely you're gonna notice it. Everything's it become red. So it looks like everything's fine. Create merge pull request, confirm this merge, and when I go back to my Azure Data Factory dev environment, I should have at the moment in my main branch 2 pipelines. Ta-da! Here it is. But as you can see, if I switch to the live mode, I have only 1. I have only 1 because I didn't publish it. So what I have to do at the moment from my main branch, I have to click on publish. When it's publishing, first of all, yeah, it tells me that I have changes. Do you want to apply it? Yes, of course. Click OK. It's deploying the changes on the live Azure Data Factory dev environment. And after that, it's creating these REM templates. These REM templates contains information about how many pipelines I have. In our case, there are 2. It's also automatically apply these changes to the ADF publish branch. As you remember, I already opened it, so I'm going to open it again. I'm going to put the IoT things, and as you can see, here it is. My changes already applied in this file. So that's good. And we just make some, let's say 20% of our goal. Let's go back to our presentation. Where Azure DevOps is in the game? Well, Azure DevOps, first of all, gives you a lot of opportunity you can do. For instance, you can track each sprint item or whatever you do on your project. You can, in Azure Boards, you can plan, you can also track each item, discuss with your teams how to be done, what to be done, etc. Azure repos give you the ability to connect it to the GitHub and also to use it as a repository. Pipelines, this is the key, gives you the opportunity to create automatically continuous integration and continuous delivery. Test plans, lots of bunches which are related to the testing, automation testing, clients feedback, advanced test systems, etc. Artifacts, well, this is something you can share with your teammates. For instance, you are building some Java code, you're compiling, and you can just drop there your jar file, and they can get it and implement it in their system. For instance, also here you can use Nuggets, Python, Maven, and many more. So it's a good idea just to have an idea what exactly the artifacts and the pipelines. Of course, here is the thing that we are going to implement, how we are going to merge and integrate all these three services at once. So, another demo. Okay, so at the moment, we know that we have changes on our dev environments, which at the moment they are applied. But when I open the test Azure Data Factory, I won't see that the new pipeline is there because it's not deployed. I don't have it. So here is the time where Azure Data Factory should be done. So, and do lots of things for us. So I already opened Azure Data Factory. Of course, I have some repos here, some projects, etc. So I will start from scratch. I'm going to create a new project. This project will be something like 2 p.m. IO demo. I can keep it private, I can keep it public. It doesn't matter. It depends on what are the team, what they decided, what are the company rules, etc. By default, you're going to use the Git version control and the work item process as a basic. Of course, you can change it. You can use Agile, you can use Scrum, you can use CMMI, it doesn't matter. For the version control, you have only two possibilities, Git and Team Foundation version control. So I will stay on Git, I will go to the working item process basic, I will keep it private, and I will create it. So when the new project is created, it will automatically bring me in. And as you can see here, we have the menu that we saw on the slide. So I'm going straight forward to the pipeline because I'm not sure that I'm going to have much time. First of all, what we are going to do, we are going to use libraries. After that, we are going to create release pipelines. And after that, we are going to create the releases. So let's go to the libraries. So in libraries, you can create variable groups. Why they are so necessary? The variable groups are something which can help you to automate your deployment and continuous integration processes. What I mean, first of all, I will create the variable groups, and after that, I'm going back to them when I start configuring the whole process, and I will tell you why they are so important. So let's go and create one variable group. First of all, the first one is going to be testing. Why? Because I need to deploy it on testing environment and on production environment, right? So I'm going to add, and I am going to put a variable which is called env, because I'm lazy as the Romanian guys. TST, because this is the test environment. Save. After that, going back to the library, create a new one. Just a second. This is gonna be prod again, env, and PRD, and save. As you mentioned, look, the env is PRD. The other one is the TST. Why? Well, because as you can see here, it's Azure case TST RG. The other one is Azure case PRD RG. And the TST and RG will be replaced with this environment. And depending on which stage the flow is at the moment, is going to replace it with the proper one. So this is very fancy, to be honest, and quite good. Okay, so we have the environments, and now we need to go to create the releases. But before we create the releases, because I don't have a pipeline, I need to create the pipeline. So let's go and create the pipeline. So Azure gives you the opportunity to use templates, predefined templates, depending on what system, what code, so whatever you use. There are a bunch of scripts which can help you to create your continuous integration, continuous deployment. But for now, I'm going to use the empty job. Why? Because it's a private case. And just to show how things are going to happen. I don't want, for instance, 99% of the all configuration to be done for someone else. And I'm not sure why if it is going to work correctly or not. So that's why I'm going to create an empty job. The empty job gives me the opportunity to put a name of the stages. As you can see here, this is the stages area. Where is my mouse? And this is stage 1. This is the name of the stage. So I'm going to call it testing. As you can see, voila, testing. Okay, close it. Now, do you remember when I spoke about the artifacts? What are the artifacts? Shared jar files, Python codes, Maven, whatever you want. In our case, we need to add an artifact, but we don't have a jar, we don't have a Python, but we have a GitHub repository. So I'm going to bind it, and in our case, the artifact is going to be our GitHub repo. Of course, if you have an Azure repository, you can use it. You have different kind of options here. So first of all, when I choose the GitHub, I need to create a service. Why? Because I don't have nothing to show. How to create a service? Click on the new. I need to create a connection, this time from Azure DevOps to the GitHub repository. I already have connection from the Azure Data Factory to the repository. Now I need to create this connection between these two systems. So I will create authorized using, find it. Everything's look fine. Now I need to choose which is the source. I have only one source, nothing else. And this is my repository. So here is the most of the configuration. Now, default branch. Default branch means which branch I need to deploy on the particular target environment. In our case, as I mentioned at the beginning, ADF publish is the most important, and it's always only in the Azure Data Factory. Remember, when you have Azure Data Factory and GitHub, always deploy ADF publish. because automatically the changes will going to be applied. Default version. Of course, I'm choosing the latest from the default branch. You can use some other opportunity, but this is the best case. Source alias, you can put something more fancy if you wish. At the moment, I just going to use like this. I'm going to add. All right, guys, I have the artifact. I have one stage, but I don't have a job who is going to get the credentials and to point to the files and to deploy everything on the different environments. So I need to create a job. So I'm clicking to create a job. Here I have an agent job. The agent job is SQL, for instance. Think about it like a SQL job. You put it as steps, which it needs to be followed by this agent job. It executed one by one. So I need to add something. First of all, I need to add Azure Key Vault. Why I need to add Azure Key Vault? Because first of all, I need to get the secrets that I'm storing for the blob storages and also for the files. And this is very important. After that, because I'm going to deploy whole resource group, I need to get the REM template deployment and just add it. Now, this is the only two steps that I need to do. And sorry, and I need to configure it. First of all, I'm going to the Azure Key Vault. I'm going to use my Azure subscription, and I need to authorize it. So it's going to take a while. I don't know why, but most of the time, when you're going to use a Key Vault, you need to authenticate against the Key Vault. And the Key Vault is checking, do you existing as a principal? What kind of permission do you have? And if everything's look fine, it gives you the opportunity to get the information from the Key Vault. Otherwise, you're going to fail. So, yeah, I'm using also the Azure for Students, but this is a long story. Yeah. So when I authenticate against the Key Vault, the next step is to choose which Key Vault I need to use. Because we are getting the information from the Dev Azure Data Factory environment, and we are going to use all the files and templates from this environment. So I need to choose the target one. The target one, in this case, is going to be test. And as you can see, nothing else. That's all. Click here, click there, and continue. The REM. REM is pretty much straightforward. So Azure Service Connection, you choose it. After that, your subscription, choose it. Here, the action, you have only two options: create or update the resource group, or to delete the resource group. Because I don't want to delete my resource group. I want to update it. So that's why I'm going to choose by default this one. I need to choose which is the resource group. The resource group in this case is going to be, again, the testing resource group. Location. Location, if you know where a resource group is stored as a location, it's going to be a good idea also to use the same location. In my case, this is the West Europe, because it's the nearest to us.
Because of the mirrors of the Microsoft infrastructure.
Yeah, exactly. So, and here I have fields which I need to fulfill. They are required. So for the template, I'm going to put the JSON file from the ADF publish branch, which contains information for the whole pipeline's activities. This file is called, give me a second to load, REM template for factory. Choose it. And for the template parameters, I also need to choose the REM template parameters for factory file. And voila. So if I want to test it, maybe it's going to work correctly, maybe it's not. I'm not 100% sure. Why? Because this is Azure. So there is something which is very interesting at the moment. There is an option which gives you the opportunity to override the template parameters. Do you remember when I created the variable groups and I put there the env and some values of the different groups? If I open the override template parameters, you're going to see that I have a factory name and some value which is pointing to the def, but our case we need to point to the to the test environment. But if I want to point it first of all to the test and after that to production, I need to use some kind of parameter here to change the environment because the values are absolutely the same. So this is very important to have a naming convention, and this naming convention to be strictly precisely keep it. Yeah, follow. Thank you. And also I have here a key vault. You cannot see it, but this is a keyword. This is the parameter for the key vault URL. And also, if I point it here, you can see that it's pointing to the dev key vault. But when I'm going to deploy the things, because the environments are different, the keys are different, I need to get the proper key vault. So instead def, I need to put it TST or PRD, depending on which stage I am. So how to do this? First of all, I'm going back to my file, REM template. And as you can see here, I have a factory name. And also I have a default value, right? Here it is also for the base URL. And also I have the default value. Great. So I'm going back to our Azure DevOps. Give me a second just to put a fancy name. 2 p.m. IoT. This is the name of the pipeline, nothing else. It doesn't really matter, but it's good to have some name. So go to the values. And now I need to configure the pipeline variables. So how can I do this? First of all, I'm going to the file, which I already opened from our GitHub. I'm going to get the factory name as a parameter. I think this is the very straightforward to see what exactly is happening. And after that, I'm going to get the default value. The default value here is def, but I want to create it dynamic. So I will put, let's say, a keyword, which is going to point, this one is going to point to the variables group. Absolutely, environment is going to get the value from there and going to replace it here. So I'm going to do it also this for the URL. Going back going to get the default value, place it here, and again, I will put the env. Okay, so I have it, right? Now, save it. Absolutely necessary, save it. Yeah, believe me. Well, it turns out that, for instance, if you don't save your key vault, you do some changes on the key vault, just forget to save it, everything disappears, and you need to start over. Yeah, going back to the tasks. And now, what I need to do? First of all, I need to replace, because I already done the mapping of the variables, I need to replace some of the values here. For instance, the TST here also is going to be replaced with the env, because depending on what kind of the variable is coming, it will get it and replace it there. Also, I need to do it for the resource group, because I'm going to deploy the resource group, which is going also depend on the variables. Yep. And in the end, I need to do the overwrite. So how to overwrite it? Because I already created the variables of the pipeline, and I know they are already dynamic. The only thing that I need to do is to put the dollar sign, and before that, just to put the name of the pipeline variable. In our case, this is the factory name. And absolutely the same is going to be for the key vote. All right. So looks that we are almost done. I'm telling you looks because, first of all, I need to get and to tell the key vote, dude, please add to your permission Azure DevOps to have the ability to get your secrets, because it's necessary to read it, replace it, and after that to continue its work. So what I need to do, I need to go to the key vote. And after that, I need to go to the access policies. So in the access policies, as you can see, even the Azure Data Factory should bring access policy here. How to add access policy? I need to select the principal. I'm going to select the principal, and because if I start scrolling, I won't, believe me, I won't find it. I will tell you one small hint. If you don't know how to find it with a whole bunch of principles, you can do it in this way. You can find, first of all, check your Azure name here of the Azure DevOps, and after that, put some unique name of your project. So in our case, it's going to be Azure Data Factory DOP and 2 p.m. IoT demo.
Followed by a first rule that you said about the naming convention.
Yeah.
So this should be. It wouldn't be hints, it should be a rule.
Yeah, but for instance, if you put it a lots of credentials to your Azure Data Factory, and you use different kind of projects, because in one Azure DevOps you can have more than one project, and they are going still to use the Azure DevOps name, you maybe gonna get lost. I will show you what I mean. So I'm going back here, and I'm going to put Azure Data Factory DOP. As you can see, this is my previous Azure Data Factory project that I used, and I bring them some credentials to it. So at the moment, that's why I'm telling you, Azure Data Factory DOP 2 p.m. IoT demo, and I know this is the correct one. So I'm going to select it. I'm going to give it 2 permissions, get and list, and I'm going to add it. And of course, save it. This is very important. If you just distract it for a moment and click somewhere else, it won't save your changes. You need to do it again. Yeah. So let's see that at the moment, assume that at the moment everything is fine. But before we create the release, we need to do something else. We need to map some of the variables. So now at the moment, I have testing. It's already done, but I want to create it for production, right? And if I start doing everything from scratch, it's gonna take me too long. The trick here is just clone it, click on it, rename it, and keep it. So you know that in testing, everything is created in dynamic way. There is a lot of replacements. Already you have some credentials, etc. So in the end, give me just a second. You need to link the variables to the proper stages. This is very important. So first of all, going to the testing, going to the stage, variables, group scope, and here you need to select the scope that you want this one to be linked. In our case, this is the testing. Click on it, link, and after that, you can do it the same for the next one, which is for the production. A link. And now, we can go and create a pipeline. Save. Create a release. In our case, this is a manual way. I'm going to release it. As you can see here, the release one is already created. Now, if everything's fine, the testing stage should be, I think, less than a minute should be deployed. If everything's correct, according to the configuration. Because I can, there is also an option in which I can, let's say, miss something. I don't know. But you can follow the logs. So, what he's doing, he's starting the agent. After that, he's going to the GitHub repo. Here it is. It's downloading all the objects for the IDF. After that, he's going to the key vault, getting the information, doing some replacements of the variables, and after that, he's deploying. If it's deployed at all, writing for Kazoo. Okay, so. If I go back, as you can see, the testing is successful. I will leave the production and I will go to my Azure Data Factory testing to see, do I have the new pipeline? Do you remember about it? I'm going to open. I'm going again here. And voila, this is the test environment, ladies and gentlemen. And I have the weight, the new pipeline, and the weight is here. So also the same thing is going to be on production if I don't have much time. So I want to show something else, which is going to be how to automate all this stuff. Let's go to the Azure DevOps. Let's go. Production failed for some reason, but I don't care. Yeah. Yeah, it's production. It's better that it's not. So I'm going to change at the moment the artifact, and I'm going to click on the trigger icon, which is like a flash. And I'm going to say I want to enable, and I wanted to add a branch, but I need to specify which branch. In our case, this is the IDF publish, because I'm talking for last hour only for this IDF publish, and I think it's logically that the IDF publish is our publish branch. So I'm click on it, and after that I'm going to close, and again save it. This is very important. Now let's go back to our Azure Data Factory. I'm going to the Azure Data Factory here. I'm going to add some, oh, give me a second to change the branch. So I'm going again, putting another weight and just putting weight 2 minutes or 2 seconds. 2 seconds, 2 minutes too long. 2 seconds, save. Come on. After that, I'm going to create a pull request. I'm going to create the pull request, and after that, I'm going to merge it to the dev master branch. I'm going to confirm this one, and I'm going back to my Azure Data Factory. Now, at the main branch, I should have this additional 2 seconds wait before the first one, as you can see. That's nice. Cool. I'm going to publish. When I'm going to publish, it's going to again create all this stuff that I mentioned earlier about the REM templates, and also for it's going to populate it, the REM for factory JSON files and parameters. But the interesting thing is that I'm going to the pipelines and going to the releases. As you can see, guys, I already have release number 2, which is automatically created and is going to deploy again the code to the testing environment, because the production at the moment, there is some errors. And let's wait for a few seconds to see how the things are going. 5 from 5, it could be 6 to 6. RM, come on, come on. Push it, baby, push it. And when it's done, I will check what is going on my test environment, if the new weight appears there. So I'm going there. I need to just to refresh. And yeah, here it is. So everything looks fine. Even more, if you want to run, you can click on debug, and after that you can check that everything is going to work smoothly. So takeaways, everything's on net. I won't provide you any link because the documentation of Microsoft is huge. You can read lots of things there, so no worries about it. Don't forget about incoming events. Data Saturday Plovdiv is in August, and in Sofia is going to be October 9. Okay, no matter. But the GS Talk is very huge event, so especially if you have a affinity for some hardcore stuff, you can go and check it. And again, thanks to our sponsors, and thank you for the time, guys.
Who's the other sponsor?
These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
Start my days, sun rays. I tap the phone, coffee's on. I mow the lawn, impressing Sean. So connected, so effective. I let it drop, clean it up. Heat and smart, I do my part. Get in the car. Super superstar. They're watching me. IoT, 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 IoT. I check my stock. What a shock. Buy some prawn. My oven's on. Coming home. Future zone. All for me. IoT, 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 IoT. Live like a Bosch with many connectivity solutions for a smarter future. From Bosch.
Независимо от работата от разстояние, в MentorMate продължихме да бъдем свързани. Работим от офиса, от вкъщи, от всяка точка на света. Това вече е ежедневие. За да отговорим на нуждите на всеки, създадохме 3 модела на работа, от които всеки в компанията може да избира и след края на пандемията. Първия вариант е комбинация от работа от вкъщи и работа в офиса. Комфортът на собствения ви дом ще бъде съчетан с социалните контакти в офиса. Може да предпочетете да работите изцяло от вкъщи, като ще имате опционално място в офиса след предварителна заявка. Искате изцяло гъвкава и дистанционна работа? Може да работите от всяка точка на света, гарантирайки си по-високи доходи. За да осъществим тези модели на работа, ще инвестираме $1 милион в висококачествено техническо оборудване, което да даде възможност на всеки да работи комфортно, независимо къде се намира. Придобивките за хората в компанията също стават гъвкави, като всеки ще може да избира най-удобните за себе си. Като компания, която цени служителите си, даваме възможност сами да избирате. Тези модели на работа важат за всички отворени позиции и не са ограничени за времето в пандемия. Посетете нашата кариерна страница mentormate.com/bg/careers и вижте отворените ни позиции.
Okay, hello everyone. It is time for the last presentation for our conference at Track 1. And it is about digital twins and anomaly detector. Thanks to Andrei Bachvarov, most of you already know about Azure digital twins and digital twins in general. I will have a relatively short overview with some main use cases. And after that, we will go a little bit more into anomaly detector. What is this? Why we need it? Where is possible to use it? What is the benefit? And we will have some demos also. So, I have small technical case, but now it is better. Okay. Again, thanks to our partners for the great support for this conference. Also, don't forget that at the end, we will have a raffle, and MentorMate offers very nice prize, so you can win this prize. This is something which I suppose many of our attendees will really enjoy. What is the initial idea of this talk? To have some overview about digital twins, to go a little bit deeper into Azure digital twins, and to see how we can have anomaly detection using digital twins in Azure and cognitive services where we have anomaly detector as functionalities which you can get out of the box. About digital twins, it is not a new idea. It is 20 years old idea, initially proposed for actually not physical systems, for virtual systems, where you can make digital replica of digital systems like product lifecycle management systems, for example. But step by step, it's a very popular concept for different business domains, including aerospace, including construction, and different very important domains like healthcare, defense, automotive. What is the interesting case when we have digital twins? You have sometimes simplified, sometimes quite complex replica of your original system. This replica is a model which can be managed and accessed from your solution. You receive information from the original system. You have these parameters in your digital replica, and you can provide on top of this model analysis, you can use this model like integration layer between core IoT services, original solution, and analytics services, which can stay not adapted in a special additional way for your solution. So you can use general analytics services, which makes solution easier for development and more applicable for different cases. You can have simulations at real time, and you can have monitoring, and you can make, based on simulations and different analyses inside, what need to be changed in your original solution to be possible, your original solution to be changed and to behave in the best way. It is something which is quite popular for sport cars, Formula One cars, for jets, and for different machines in general. As more expensive is one system, as higher is the value to have such kind of digital replica. But nowadays, we have more and more this approach applicable even for more common systems, not just for very expensive systems. We also can use digital twins for modeling, for prototyping. We will talk a little bit later about these things. It is very popular also to use digital twins for energy models and optimization, something which probably some of you already saw at the presentation for track 3 at the previous time slot from Andrei Bachvarov. And also, it is possible to have many different types of analysis regarding to buildings, structural engineering. This is one of the areas where we have really very good application even now for digital replicas and digital twin. Health monitoring, that means you can have actually all these activities regarding to monitoring of specific structures, regarding to safety and maintenance, optimizing the maintenance cost. And you can use also this approach in prototyping, materials testing, something which can be done in different way. But why not to have one common approach for this? Why not to have the same approach for different problems? Actually, this will simplify the overall cost of your solution. Just visual representation, what is possible to be done based on your regional solution. You will have replica where you will have all these options to monitor, manage, maintain this solution, make analysis, make predictions, prevent some failures. Nowadays, you have also something which is more related to marketing and sales for many systems. Behavior which you have, like owner of these systems, for example, you are buying a car, you are buying a truck or something like this. Usually more expensive systems have replica, data is collected for these machines. There are some analysis, and based on this, the manufacturer provide you options to upgrade. Next models will be based for something which is based on analysis and the current solution. Also, software updates, some new configurations proposed for the solution also can be done based on digital twins. So from one side, manufacturers and sales can upsell in this way. From another hand, the real clients can be more happy in general. But most of cases which we have are mainly related to integration between regional system and digital services which can be used for different analysis around your replica. Just a few words about what is differentiation between simulation models and digital twins, because I started to talk about simulations. Simulations actually can be done with digital twins, but currently existing from the past models for simulation mostly have different goal, and they are assumed to actually be used for analysis based on some simulated load or some parameters for your system, but not for bidirectional communication, because what we have in digital twins is that from one side we can model our solution, we can prototype it. Digital twins concept will replace different approaches, like for example in construction, building information modeling, where you have already standards how to prototype different buildings. Why you need to have different standards, why you need to have different techniques. You can use the same approach for this. So it is something which actually brings you additional value. One common concept for simulation, for prototyping modeling, for monitoring, for real-time analysis, and integration with other services in your back office. So this is in general, with few words, what we have about digital twins. And because we have not much time, I'm trying to go ahead a little bit faster with slides and explanation of the concept. Why IoT stays so popular around digital twins? Because as we already discussed, digital twins is not a concept only related to IoT. It is not a concept related only to AI. Usually we put this approach in area which we name mixed reality. But one of the main role is actually to be some kind of integration layer. From one side, you have replica, digital replica of your solution, but this digital replica can be much easier integrated with any third-party services, any additional solution which you need to have some kind of analysis, maintenance, whatever. So this is probably something which is very important. Do we need really digital twins? Do we have alternatives? Yes, we have. You can implement this actually using custom implementation. If something happens in your solution, for example, if we have an air condition or any kind of equipment, it is possible to send this information, to send some message. This message will be analyzed. You will trigger some business logic in your solution, and you can make custom implementation. But custom implementation usually increase complexity of your system, and support is very difficult. So if we have some more formal approach to do that, actually we have easier for maintenance solution. We have the same approach for different kinds of solution. We are able to reuse this approach for different business domains. So we have one formal approach to solve different problems. And if we talk about digital twins, we have many implementations. One of the implementations which we really need to consider a little bit more deeper is Azure Digital Twins. I am not here to be some kind of evangelist of specific technology, but based on experience and different implementations, this is probably the simplest available for end users without any specific restrictions and requirements platform where anyone can actually start use this platform and build different types of models. So we will talk about advantages. You can have very complex models using spatial intelligence graph. We'll talk about this, of course, a little bit more in details. We will be able to collect data. Let's try to clarify. Digital twins is not a database. Digital twins keep the current state. Data, historical data, need to be persisted somewhere. You can use digital twins to represent at any moment of timeline behavior and state of the solution, but digital twins keep the state of solution at a specific moment. And after that, new data is coming, and this data, which is already historical, is good to be persist somewhere. But do not consider that digital twins is database. So just collecting of data is, of course, possible with digital twins. Yes?
Digital twin is a model. It's not just data, it's a model.
Yes, it is a model. It is a model which represents the actual state. Exactly. Actual state usually, but you can, at specific moment, if actual state is with some issues for the system, you can actually keep this state for a specific timeline, provide analysis, for example, to see the behavior, and after that to continue. You can have also several different replicas of the same solution if you need to, from one side, to monitor the last state and to provide some analysis. But yes, you keep the state of specific moment. That is the case. And you have also a very good options for so-named role-based access control. Why, in general, this problem is here. Probably this is something which you do not relate directly. I can explain. Usually, when you have IoT solutions, one big problem for complex enterprise solution is to have permissions when you have several layers. For example, you have building. In this building, you have some equipment. Building is managed from one organization. Equipment is actually produced from another organization, and it is rented from third organization, which can be used for the first one. You can imagine such kind of matrix structure with partial overlapping of different areas and different type of equipment in the whole structure. So at this moment, you realize that you need complex model to represent role-based access control, which is actually simple, something straightforward just on abstract layer for information systems. So you can use here also digital twins concept. And not at the last place, rich integration, because integration is one very important thing in the whole digital twins concept. How it started? It started with IoT mostly because one very specific reason: state of the devices. State of the devices is something which gives you opportunity to reconfigure devices, to make software updates, and it is actually an essential part of every complex IoT solution. Based on this, here in industry, we had one of the first really massive applied implementation of simplified version of digital twins concept, which main software vendors actually use. In Azure, it is device twins, where we have actually described with JSON structure of the state of the devices with different properties, configurations. And from another hand, in AWS, we have device shadows, which are pretty similar. Device twins are a little bit more cleared because some of additional functionalities are in Microsoft Azure Gateway Service, so named Azure IoT Hub. In AWS, we have some of these functionalities partially in device shadows, but it is mostly because of the general concept. My point is that we have, for such solution, very good application of simplified version of digital twins concept. So every time when you need to update software of your devices, we are solving one already, I can say, straightforward task, but very important. Usually devices have their current state, and when we need to change something from the back office, we are creating so-named desired state, set of configurations. Usually, in the modern IoT solutions, we are implementing so-named service assistant communication architectural pattern. That means both sides, devices and backend, actually, let's try to use laser here for a while. So devices and backend need to be protected. In the old school solutions, we have protected devices because computer power in for devices, even with growing of options for these devices, is not the same like in the cloud, for example. But we first trying to protect device. And in the old school solutions, usually the main vulnerability point was gateway service, where we accepted connections. But nowadays, it is in a little bit different way. Usually, we have gateway service, IoT hub, and also other implementations in a way where you have service-assisted communication. That means you have two queues or two group of queues. One queue is dedicated for writing only from devices, and backend services can only read from this queue. And another queue is dedicated for writing only from the backend services, and devices only read from this. In this way, you have only this service actually with option to accept connections from outside, but no one of other parts and services actually accept connections. They initiate connections to IoT hub or to gateway service in general. So in this way, we actually have from one side security, and here also the approach to update devices is very attractive, because you can have device twins, or for Amazon AWS device shadows here, and both sides just connect gateway service, sending from the backend desired configuration, reading current configuration. Usually logic for update is on the device side. It could be for the backend, but in the classical way, when device read, for example, desired configuration, they understand, well, our configuration need to make some changes. Okay, there is information about from where to download new packages or something different, and device is trying to make an update, and device is trying also to make changes in its configuration. It is possible to be done in different ways. I'm explaining just one of possible approaches to do that. So, what about different platforms? In documentation, you can see different options, but main vendors usually explain that they support digital twins like part of their platforms. What is the reality? In GCP, we have set of services, and you need to build from yourself digital twins. Of course, it is possible, but you have no ready for use digital twins services. For AWS, including device shadows, for real complex multi-purpose digital twin solution, you have recommended design, how to use several services. Again, it is not something out of the box. You can use recommendations like architectural good practices, and to build your solution, but at least more clear and simpler than in GCP. What about Azure Digital Twins? Azure Digital Twins is probably the first for mass usage digital twin service which is available in the cloud. Let's be clear, it is not the only one digital twins implementation for common purpose, but most of digital twins implementations are mostly focused for specific domains. Mostly they are implemented from companies working in specific domains and IoT, for example, like PTC, and the price is higher and focus is implemented in a way where it is very easy for specific tasks, but it is not real general purpose solution. This is something which I would like to explain. About Azure Digital Twins, it started in 2018 with the first preview. I will not spend a lot of time here, just several points like specifics. First preview of Azure Digital Twins used IoT Hub like essential part of the core of this service, which actually gave you limited, but just limited flexibility, because you needed to have with each instance of this service also IoT Hub. In reality, it could be much more flexible and complex, and in the current version, as we will see, it is actually decoupled. regarding to different solutions, you needed to have actually some specific options where to use digital twins. From one side, you are able to use it for integration with devices around gateway services. From another hand, it was possible to use it also for modeling and analysis, and it was possible to use it for integration with different solutions in the backend. So nowadays, as I mentioned, integration with IoT Hub is in a different way. These services are decoupled. So the second preview, which actually stay the base for the current general available service, appears in 2020, and in November or December 2020, actually, we had the general availability of this service. About latest version, what is the difference? The difference is that from one side, we have much more general approach for modeling. We have some limitations which are not hard. That means you have service which, when you create and deploy, has some limitations regarding to good practices to not overload the platform. But if you have some specific requirements, you can ask Microsoft support and they will remove these requirements. Just it is a standard approach for platform vendors to prevent their services from not very effective use and not optimized setup of the platforms. So what is probably the main advantage? First, we have common language for modeling, so named DTDL, Digital Twins Definition Language. You can have JSON-like syntax to create your models. And it is possible to have different preprocessors for this, of course, but you can write it if you have understanding about how modeling actually is done. Main principles, you can use just a simple text editor and it will work. Integration with other services. Initially, Azure Digital Twin Service used more out-of-the-box approach for integration, but nowadays it is mostly with HTTP and calls. Here in the slide is Azure Functions, but actually you can have calls to any HTTP endpoint, and it is general approach to integrate one service with other services. So we have much more straightforward approach for this. We have for input, simplified input from several services, but for most of services, we need to have such kind of approach with HTTP end calls from one side to call other services when it is needed, like output and some triggering of the logic, and from another hand, for input from different services, we have three options for direct integration, IoT Hub, Logic Apps, Azure Functions, but we can also implement custom integration with any other service using web services or Azure Functions or Logic Apps, for example. We will see there is also option to use open source Explorer. Explorer is a simple application written on React, but it is not with so limited functionalities. You are able to generate relatively complex models. If you really need something very complex and huge, you can use also preprocessors implemented from Bentley microsystems, And also from ANSYS, they have very good preprocessors. Also, Autodesk is working also for preprocessors for Azure Digital Twins. The idea is that other software vendors recognize this service and start to integrate their solutions with Azure Digital Twins, which is good markup for the case that really this service is attractive also for other vendors. How we integrate solutions? Let's see, we have a few minutes. In most of cases, as I explained with Azure Functions or any kind of web services, you can have integration where any service which is source is sending, for example, with HTTP and call to specific your service some information. This information is sent to API of Azure Digital Twins. Again, most of schemas are with Azure Functions, but to be clear, it is not necessary to be always Azure Function about this. We have good event routing approach. So event routing approach actually is based on the option when you have the whole model that at the end you have common endpoint where you actually can be subscribed for all these events and to make routing and to trigger different business logic about this. And relatively standard operations. For example, we are collecting information for sensors. In our model, we will see something like this. We can use, for example, event grid or to have actually distribution of these events. It is possible also to have logic where based on some triggering to make corrections into your model. Corrections means, for example, if you have, for example, temperature which is higher than expected in specific room, for example, if we have buildings, and you receive this information, you can have logic where there will be changed the setting for this room that air conditioning need to actually compensate this. Yes, yes, exactly. This is the main approach. How looks modeling with DTDL? You have JSON with relatively simple elements. You have unique identifiers. You have several types of components, and you can have from one side properties. Properties can be persistent. You have also metrics which represent current state of the solution. We can have Azure Digital Twins in different solutions in the following context. I already explained integration. I already explained role-based access control and making our gateway services available in specific ways based on the permissions for very complex solutions, also for analytics. But there is another option. Sorry for the probably relatively small diagram. This option is related to so-named device configuration management of the whole solution. Usually in IoT solutions, probably some of you know about this, we have specific subpart which is named device configuration management. This is the subpart which actually is responsible for the things around device maintenance, device provisioning, and usually in the past, it was something which we needed to create like custom solution. Nowadays, you can have the most of these device configuration management system based on digital twin service, and you can simplify the work for implementation of such solutions. So about the model, I will not spend a little bit more time. We needed to discuss that nowadays for the latest version, everything which you need to implement like part of your model is absolutely flexible. In the previous preview, it was with some hard-coded objects, and you were able to extend this object, but nowadays it is absolutely flexible. You can start from scratch and to describe your model without any mandatory elements which give you flexibility. Here we have, of course, details about what we have in digital twins definition language. Again, we have a relatively small timeline, short timeline, sorry, and that's the reason to go ahead. But you have two types of data, property and telemetry, as I mentioned. Property is something which actually can exist for a long time. Telemetry data usually comes and you forget about it, yes. And the whole model can work with this data, and other services, of course, can connect to Azure Digital Twins and to realize the real state. About security, everything which we have in Azure services is available. The straightforward role-based access control for the whole service. Please realize the difference between role-based access control for the solution, which I explained, where we manage complex organization, and role-based access control just for Azure Digital Twin service. Here we are talking about role-based access control for the service. That's the reason to talk about this exactly in the security context. We have two specific roles which are not typical for other Azure services, Azure Digital Twins owner and Azure Digital Twins reader. Owner actually is owner of data which we have in the service, so you are able to read this data. And reader just can consume data. In general, reader cannot reconfigure the digital replica. And we have, of course, digital different scopes here. High availability, disaster recovery are managed from the platform, so you have no need to think about this. Actually, it is. Yeah.
In the Microsoft Cloud, there is no disasters. Only the system administrators, data centers know about the disasters.
Well, this is another point of discussion. About disaster recovery, we are talking if we have general failure for the whole region. Well, some disaster, for example, earthquake or something, if happen, theoretically, you need to have disaster recovery site. Well, in the cloud, this is something which for some services can be out of the box, depending on the software vendor, platform vendor, or for other services, you need to implement it manually. For Azure Digital Twins, you have no need to think about this.
Yeah, because they have a CDN structure all over the globe. They're integrating with cables and traffic all over.
But you have global structure with many different regions, but there are some practices how to implement the security and high availability and disaster recovery. And disaster recovery usually is related to specific settings. Sometimes you need to set it, sometimes absolutely you have no need to care about this. How actually you will have the same replica in different region, yes, but not just replica of data, but fully functional service. For example, for West Europe, if something happened, to have the same in North Europe, yeah. Yeah.
You reroute the data for
Yeah.
every of your plans and services.
Absolutely. So that was the context here, to be clear. And before to have a few demos, just some things about what is anomaly detection and why we need anomaly detection in general. So the idea is that in many cases, in IoT very often, not only in IoT, but in IoT very often, we need to analyze some time series and the case if we have something, some values in this time series which are outside of the expected range, but it could be not so clear. It could be not just some kind of restriction. It could be much more specific logic. And we use different algorithms for this. So you can have such kind of diagram, for example, for some behavior of some machine, for example, and depending on differences from your expectations, you can catch some anomalies, but anomaly does not mean always that you are just out of some range. You can have much more complex logic about this. And here we have two groups of techniques, multivariate and univariate. Univariate were available from the beginning for anomaly detector, and these techniques actually are simpler. These techniques are focused mostly on analyzing of specific isolated time series. It is pretty simple. No need to understand algorithms. You need to have some general insights. I will provide some information about this. For multivariate anomaly detection, it is a different case. You can analyze together many different time series from different parameters. It is really complex analysis. For multivariate anomaly detection, you need to train your model. In the context of Microsoft Azure, you can do this in the following way. It is predicted to be used from people who have no need to work with machine learning directly and data modeling, but they need to train models with different subsets of data which they expect from their solution. So if you have many parameters for your solution, you need to actually train your model with different subsets where to specify what kind of sample data is appropriate and where you have probably some kind of anomalies, because you can have anomaly also based on some very complex considerations. So from one side, you are using algorithms from statistics. From another hand, you need actually to have additional setup to be clear what exactly is expected from this data, like
if we have
output.
factor that is exploded,
Yeah, something like this. Well, for multivariate anomaly detection, probably we need to have a separate session because it is a relatively complex case. The good thing of Azure Cognitive Services is that you can have this service actually to train your model without to go directly into machine learning with some interface to manage your models directly in machine learning. That means you need to have insight about how your solution works, but you have no need to understand in details what you need to do with machine learning. For the simplest way, of course, is univariate. So I apologize, but we will have demos with this because, yes, for other things, need to have good setup, more complex setup. Hopefully, later this year, I will have time to propose something like this. For multivariate analysis, you have something like this. Many, can be represented like this. It will be probably the right explanation. When you have different series, you can have, based on this analysis, actually the right specification where exactly you have some problems. Let's go back to this simpler univariate analysis, which we have in more than year in anomaly detector service. Anomaly detector service now is general available, but multivariate anomaly detection is still in preview. So in the past, this service was actually realized like additional API for Azure Cognitive Services with only univariate analysis, and after that it stayed general available, and after that, like preview, was added options for multivariate. But what exactly we have even in the simplest option with univariate? We have set of algorithms which can be used, and your service do most of the things automatically. What I mean, you need to send series of data. It makes feature extraction. That means it analyzes your data and make classification. Based on classification is using different algorithms. If you have some seasonality, that means repeating samples of some behavior, or you have, for example, not such kind of repeating pattern, but you can have more coarse granularity or more fine granularity, and based on this, you can actually have the best setup for analysis without to know about this. You have no need to think about this, which is really something. It can sound populistic, but like democratizing of artificial intelligence in the context of anomaly detection, because everyone can start to use it even without need to go deep in this area. So in the service, we have these steps, as I already mentioned, extraction of values, selection of algorithms, and after that, there could be several actually analysis. It is not expected with one approach to analyze the problem, so there could be several interactions, and finally you have this filtering of anomalies. And there are two options to have from one side analyzing of the whole series and to analyze the last point. If you have live data, it is pretty simple to have after first analyzing a list of values for the next one, just analysis if this last value is with some anomalies based on the previous. So we have such kind of options, and based on what kind of approach you are using, you can get or to not get some specific local anomalies, as you see here. For example, if you are detecting the last point, sometimes you can be, for example, in a situation where you are able to analyze this regarding to specific previous sets, but if you have the overall analysis, you can have actually ignoring of some small anomalies based on the overall picture. So, in general, the time series are pretty simple. You have timestamp and value, and you have series. You can have different granularity, daily, hourly, minutely, if you want, seconds. It is not mandatory, but if it is important for your solution, you can put it. Otherwise, you will. Yep. Okay. You need to have some kind of preparation of your data. You need to have the same interval, so you need to prepare your series, and you have several endpoints in anomaly detector service which you can call in general. And the implementation details you will see. How we can integrate these options. With digital twin service, you can, from one side, have output to some messaging services like Event Hub, for example, and to have application which is subscribed to Event Hub and send this information to anomaly detector service, for example. If you want to have some analysis which is not at real time, you can just persist data, and after that to read it with client, simple client, which is implemented based on anomaly detector service. Now I will try to make some demos for the last 2 minutes. Not much, but probably enough. So let's see if I will need to share probably the whole screen, the first one, and I will actually make the following. Device simulator. Sample simulator, which is sending data, simulated telemetry data to IoT Hub. IoT Hub is already created. I will make the following because it is in the stream, but it is not here. Because, but from another hand, I need to see it. Yes, need to duplicate. So, okay. Yes. So we actually have some sample data. For example, sample data here includes temperature sensors. These temperature sensors actually here are realized like part of our model. So we have already created digital twins model, and we have here, let's see if this is the right model. Give me a second.
This sensor is on JavaScript. Sensor simulator is on JavaScript.
Simulator is .NET, .NET Core, but this application, which I'm using mostly to represent the model, give me 1 second, and it will use Digital Twins Explorer will actually demonstrate the model now. It is already JavaScript. It is a React application with Node.js. Now, because I'm running this on the local machine where we have also streaming and other services working, it will run relatively slow. It is possible already to use as a service the same projects deployed from Microsoft for end clients. So you can just use some endpoint and to use already deployed solution in the cloud. But I have here the source of the open source solution. Actually, in the moment, we are running this open source solution. It is slightly slow to start, but it is just because on my local machine. And yes, we can have many complex models. Just what I explained here is that we have here this simple situation where just for demo purposes, we have actually several nodes. We have floor, room in the floor, and one sensor just for demonstration. So let's now try to run the service which is consuming our data from the sensors via digital twins. Yes, this will be the right service. I add in the service not only writing, printing on the screen of data, but also writing into JSON file. It will run after a few seconds. We will be able to see values from the temperature sensor and also to save it into JSON files. And after that, we will execute on the detector client to look at. Yeah. I have for the previous version of digital twins implementation with live connection via Event Hub, but this implementation here is with persistence of the telemetry data into the storage. Just to see what is the not in debug, I will run it without debugging. This is probably the problem that actually we needed to make it faster. Now I'm aware that it will be much faster. Meanwhile, I'm just cognitive services actually in the marketplace. You have a directly anomaly detector, but it is cognitive services instance. You have key endpoint which you need to configure in your client. Let's see what happens. Okay, process authentication. Authentication is via Active Directory. So now we need to be redirected. I hope that it will be in the same screen, but let's see if it is not where I am expect. Yes, it is here, and I will sign in with corporate account. And you are able to use some command. For example, just to here, which we need to have is observe properties. I just prepared this in advance. So if we put it in this way, we will start to receive information from digital twins. It is the current information. So we have one simulation. It is sending the IoT hub information, which after that is resent like output to Azure Digital Twins. And I have another application which is consuming this data for specific sensor from Azure Digital Twins. And in the same time, this data is persisted into specific file. This specific file, let's have at least more than 12 records to be possible to make some analysis in our series, because for time analysis, for time series analysis in anomaly detector, we need to have at least 12 values. For example, in a specific way, here we will have something like such kind of file. It could be, of course, formatted. It is not so important. And I already have another project where reading such file, you can make request to anomaly detector. And for example, you can have some analysis. For example, here we have no anomalies in the current case. If we wait a little bit longer, probably we'll have some values which are outside of the range. But this is the general approach, how everything works. We have not much time to explain a lot of details regarding to the whole setup. It was mostly introduction call, but thank you for attendance. I think that this was the most important regarding to how we can apply anomaly detector. If you have any questions, I will be glad to answer you. And we will have now the raffle from our partners from MentorMate with a very nice feature. Thank you. I suppose that it is better to have the raffle now, and if you have discussion to be after that, to not extend the timeline for the whole event. So I will invite now our partners. We have really awesome robot.
So I know there's a 5 of them. So at least one should be.
So yes, we will probably need to change the device or not. How we will proceed? Do you need to have your device connected for this raffle?
Honestly, I don't believe I can show you.
So you're welcome.
Let's do it easier.
Whatever you say.
Again.
Is your credential?
There's the camera
Okay.
on your back.
So we are ready. And just to show you. And the first one is Trifon. Only Trifon. Okay, and he win a backpack. So we are continuing with the second one, and the winner is Miroslav Nikolov. Okay, I hope one backpack will come here, but maybe the robot. Next one, Todor Popov. Okay, one backpack. Next one, Bancho Petrov. Okay. And the final backpack goes to Anton Bubokov.
I think he was there in the past, but yes, he's not here.
Okay. And the robot builder goes to Martin Ayazov. Congratulations, guys. And yeah, once again,
Thank you
thanks.
very much. Do you want to say something additional about MentorMate, why you support us?
We support, honestly, MentorMate support a lot of, we believe that as a company, we have to do that and we have to support the branch itself. This is why we support you and such conference. This is why we also organize a lot of events ourselves, because we believe that this is how we will grow the IT field in Bulgaria. I'm happy that I was here today and I managed to see so much people here, having in mind the last year. And yeah, if you have any questions regarding to MentorMate and our open opportunities, I will be happy to discuss it with you in the future.
Thank you very much.
Thanks once again.
Thank you very much to be in this event today. And it is time to close this event. Thanks again. And you can be with us next events in the fall and end of the summer. In August, we have two events. Data Saturday in Plovdiv, 28th of August. In 18th of August, we have probably the biggest summer IT event in Bulgaria, BRGS. We have in October, Data Saturday in Sofia, 9th of October. And of course, the biggest event in Bulgaria for IT specialists is Jazz Talks. It will be on 19-20 November 2021. So you will be available. If you are available, we will be glad to invite you there. This event and other events will be implemented in a way where we will have also in-person attendance and online streaming. But if you want to see some friends and if you want to win some awesome presents like this robot, you need to come. Thanks again and see you next time.